If Docker got you confused, do not worry. I am here with you. In this complete Docker course, we are going to see 4 phases, and in every single phase, we are going to learn important Docker concepts which will help you in your development journey. At the end of this course, I will also provide you some interview questions which will help you in your interview. And once you complete this Docker course, at the end, you will be able to create your Docker image. You will be able to create containers. You will be able to publish Docker image. Finally, you will be able to Dockerize your complete application. So without wasting any time, let us start with the course. Think about this. You and your friend both are working on same project, and you have got the responsibility to build complete backend. So in backend, what we will have? We have Node.js, we will have MongoDB, as well as we will have Express. As you have built complete backend, so whatever code you have written, that will be working in your laptop. So what you will do? You will just send this complete code to your friend, and you will simply say run npm install and start the project. It will work completely fine. So what your friend will be doing? Your friend will take this complete code, run npm install, and he will start the project. After 2 minutes, you will get a reply from your friend stating he has got some errors. So of course, in this situation, what you would have told, it was working on my machine. So this is the exact problem why Docker was created. If you're building very beginner level project like to do application, front application, in that everything is under your control and everything feels smooth. Why? Because you are solo developer, you are using only one laptop and you are having complete environment ready. But in software industry, the real problem arrives when we are working with larger team and that complete team is working on same project. Suppose this is company, okay, this is one company A, and this company is running some backend. And to run this backend project, what we need? We need Node.js, we need MongoDB, we need some global packages, some environmental variables, and maybe some specific commands. Now imagine we are having 100 team members, and all these team members have already set up this complete thing in their system. Now just think, one more new developer joins the team, and this new developer is having Windows operating system. Obviously, if you have joined the same team, then this complete project you should have in your system as well. So what happens here? The entire setup has to repeat manually. They have to install Node.js, install MongoDB, they have to match the versions, they have to install packages, they have to configure commands. Each and everything has to set up manually. And this is where the real pain begins. The problem is not just the installation, the real problem is recreating the exact same environment, because software projects are not just the code. They are attached to specific node versions, specific database versions, OS specific commands, hidden dependencies, as well as some configurations. Even if one of the thing changes, you will have bugs, you will have errors, and lot of weird issues start appearing. The first problem is manual setup. Whenever we are doing manual setup, we will have lot of mistakes. Sometimes wrong packages gets installed, some dependencies might be missing, as well as some configurations we would have forgotten. And in real projects, we can have huge dependencies. Sometimes our project also need Redis. Okay, sometimes if we are using some backend or if we are using some larger application, we need Redis, we need RabbitMQ, maybe we need Python, as well as we can require some Linux packages. Okay, specific Linux packages. So here setup itself become very huge. Second dangerous problem, version mismatch. Suppose original project was built on version 16, and now the new developer, what they have done manually, if they are setting up, they have installed version 20. Now technically everything will be working fine, but at some point suddenly you might see random bugs will appear, packages start conflicting, unexpected errors happen. And these bugs are very dangerous because debugging becomes very difficult because both the versions are conflicting here. Third and major problem could be these problems are not only limited to developers' laptop, it can also happen in production server. Because in production as well, we are going to recreate the exact same application. Even if small things like versions, dependencies, if anything changes, then in production as well, we can face lot of issues. If you're working in smaller team, then definitely you can coordinate and you can fix the issues. But if you're working in larger team, managing errors and managing everything will be more complicated and chances of errors will also be increased. And one more hidden problems which can arise. Just imagine we are having one member, team A, and another member, team B. Okay, both are from different teams, and this one team is using Windows and another team is using Linux. But both the teams are working on same project, and whatever original application was built, it was built using Linux commands. For example, we can have shell scripts, we can have Linux path, as well as we can have CLI utilities. And these same commands might not work in Windows operating system, as well as it will not be working on Mac OS. Then suddenly what happens? Our commands stop working, versions are different, dependencies clashes, hidden bugs appear. And bigger the team is, bigger the headache is. Sometimes code is stable on version 16, but some packages might break on version 20. Sometimes npm start work on one machine but gives error on another machine. And the most dangerous part, developers might feel the code is working on my machine, then why it is not working on others' machine? So here the main problem is not inside the code. The main problem exists in setting up of environment. Now imagine this. What if we could package entire thing and share complete environment itself? Not just the code, complete environment itself we can easily share. Inside that environment, everything is already prepared. Node.js is installed, MongoDB is configured, all the dependencies are already installed, correct environment is set up, everything inside one ready-made package. No setup, no dependency issue, as well as no version conflict. That is exactly what Docker does. So, what Docker will be doing, Docker is going to package your complete application along with its complete environment into one standardized unit, and that unit is called as container. So, just think of a container like lunchbox, and inside this lunchbox we will have application, we will have a complete application, we will have all the libraries, we will have dependencies, we will have runtime, whatever configurations are needed, all the configurations will be present. Everything will be packed together and everything will be existing independently. Now, this same lunchbox can be used on Windows machine, it can be used on Linux machine, as well as it can be used on Mac OS. It doesn't really matter what host machine you are using because the environment inside the container always remains the same. And one more powerful feature of Docker, suppose we are having one Windows machine and inside this we are having two projects, and this project is dependent on Node version 15 and this project is dependent on Node version 22. Normally, in one single host machine, this is not possible. But if we are using Docker, Docker containers will be isolated, which simply means container 1 can use Node 15, container 2 can use Node 22, and both projects can run peacefully on the same machine without affecting each other. Now, one more important point you should understand, not every project needs Docker. If you are solo developer, if you are building beginner level project, or if you are building small project, then small and simple setup is also fine. You do not need Docker in that kind of projects. But the real problem starts when the team becomes bigger. If you are having lot of team members working on the same application, during that time, definitely Docker is very, very helpful. And why Docker is so popular? Because Docker is heavily used in startups, big tech companies, cloud platforms, DevOps team, microservices architecture. Especially, Docker is helpful when we are having multiple developers working on the same project, multiple environment exist, and applications are deployed in production. And if our system needs scaling, then in all these cases, Docker will be very, very helpful. In simple words, Docker is a tool which packages your entire application along with its complete environment so that it runs same on every single machine. Let us deeply understand what exactly Docker container is. Thinking Docker container only as a bundle is not enough. To understand Docker container deeply, imagine this. Suppose you are having one gaming setup, and to run a game properly, what basic things you need? You need some graphic drivers, you need some DirectX versions, you require game files, as well as you should be having proper settings. And even if one of the thing is missing, either the game crashes or it may not run at all. Now imagine, what if game developers only send game files to you and they will say set up everything manually by yourself? That would be extremely painful. Exactly the same thing happens in software development. And our application is not just the code. As I already mentioned, it is not only the code. It also depends on runtime, libraries, dependencies, configuration, environment setup, as well as behavior of the application. And if any one of the thing is missing, then whatever application we have created, it will be behaving completely different. Docker says don't set up environment manually every time. Instead, package the entire environment together. And this packaged environment is called as container. A container is basically an isolated mini world. So inside this container, what we will have, whatever application we have created, that application will be present. If you are using MERN, then complete node configuration will be present. All the libraries, whichever we have used, that will also be included. Whatever dependencies we are having, that will also be included. And finally, if we require any tools, then all the tools will be included inside this container itself, which simply means whatever application you have created, it will be getting exact same environment as it was originally built. Okay, inside this container, we are going to get the exact same environment how we have built in original application. And because of that, bugs are reduced, conflicts are reduced, setup becomes much easier. Now suppose we are having machine A, and inside this we are having node version 16. And for MongoDB, we are using version 6. And inside this machine, we are also having some libraries. Okay, we are building one application. Inside that, we are using Node 16, MongoDB version 6, and we are having some libraries which is used to create the application. So using all this configuration successfully, we are able to run our application in machine A. Now what I want, this exact same environment I want inside machine B. Okay, inside machine B, I want this exact same environment. Normally, what we will do, we will install Node.js, we will configure MongoDB, we are just going to set up all the libraries and whatever dependencies we are having manually, step by step, we are going to configure each and everything. And this is where real problem begins. Docker takes completely different approach. So basically, using Docker, what we are doing manually, we are not going to set up entire thing. Instead, we are going to package a complete application, package all the dependencies, basically packaging entire environment inside one container. Then whatever container we have created in machine A, we can simply move that container to machine B. That's it. No manual setup, no reinstallations, as well as no recreating environment. And the most powerful part is this machine B can be Windows, it can also be Linux, as well as it can also be Mac OS. It does not matter original application was created in which host machine. We can easily create the container inside that, and exact same environment we can share to any machine. And this machine can either be Windows, either be Linux or Mac OS. It really does not care. That is why containers are called as portable. Portable means container can easily move, shade and run on different environments. It is exactly like we are using same USB cable for different laptops. Another huge advantage of Docker container is they are lightweight. Containers get started fast, they can be created very fast, as well as deleting container is very simple, and their size is comparatively very small, and because of this multiple containers can run on same host machine. Now we are having one more interesting real use case. Suppose you are having one laptop, and inside this laptop you want to run two projects. One project should be using Node 16 and another project should be using Node 22. But usually inside one host machine only one version can be installed and downloaded. But with the help of Docker, what we can do, we can create containers. Okay. And inside this host machine, we can create multiple containers. Now this container can use Node version 16 for one project, and this container can use Node 20 for another project. Why? Because containers will be isolated, and whatever we are installing in host machine, that will not affect the container, and whatever we are installing in container, it is not going to affect the host machine as well as containers, because containers are isolated in nature. So inside same machine, we can use different versions, we can use different environments, we will not have any conflicts. So there will not be any conflicts related to versions. And this is the exact reason why Docker has become so powerful in modern software development, because now development becomes easier, sharing becomes easier, deployment becomes easier, scaling becomes easier, environment consistency is maintained. Now here comes an interesting question. We have been talking about containers for so long, but where does this containers actually come from? Does Docker magically create these containers? The answer is no. Behind every container, there is a blueprint, and that blueprint is called as Docker image. First of all, let us clear one myth. Docker image does not mean any photo, it is not any wallpaper, as well as it is not any screenshot. So basically, Docker image is nothing but it is one executable template. Inside this, we will have all the instructions how the container has to be created. And inside this one single image, we can create multiple containers. And inside each container, we will have isolated environment. So here, suppose we are having project 1, we are having project 2, we are having project 3. Using this one image, we can create multiple containers, and inside each container we can run different project, because containers are isolated in nature. So in simple words, you can tell image is nothing but it is package of instructions. So what kind of instructions we will have inside the image? It will tell what Node.js version has to be installed, which dependencies are needed, what are the files which has to be copied, and how our application should start. So all these kind of instructions we will be having inside the image. Using these instructions, we are going to create our containers. Basically, in Docker, this image will be telling how exactly the container has to be created. Now let's understand this Docker image with simple fun analogy. Think of a Docker image as a burger recipe and the container as actual burger itself. Inside the recipe, basically, we will have instructions for preparing burger. So basically, we will have what ingredients has to be used, how the ingredients has to be washed, how many quantity of ingredients has to be used, for how many minutes it has to cook. And using the exact same recipe, we can make multiple burgers. Exactly the same way, from one Docker image, we can create multiple containers. But if you're coming from a programming background, then you can think like this. Docker image is a class and Docker container is an object. So what is class? Class is nothing but blueprint, and using that class, we can create multiple instances of an object. In the same way, Docker image is only the blueprint, and from that image, we can create multiple running containers. Now here comes very important real world concept. So basically, in large organization, developers, they do not share containers. Instead, they will be sharing Docker image. And inside the Docker image, we will have all the instructions how the container has to be created. Image is nothing but blueprint, so this will be very lightweight. Okay, inside this, we are not having any installation, we are not having any dependencies which are installed inside the image. It is only a blueprint, so that is the reason it is very lightweight. And using this image, developers can create the container, as well as developers can easily download this image. Once they download the image in operating system, they can easily create containers in their own operating system. Doesn't matter which operating system they are using this image, they can easily create the container. From same image, we will be using same environment, we will use same environment for the project, but we can use in different systems. And this is the exact reason why Docker is so scalable. Suppose we are having 100 developers in a team. So what we will do in this case, manually we will not be creating 100 setups. Okay, if we do, it will be time consuming, or maybe we will have lot of errors. Instead, what we will do, we are just going to share this Docker image. Okay, previously we have seen we have created the containers, and these containers can be easily moved from one machine to another. But actually, what we are doing, we are just sharing this Docker image, and using this Docker image, containers will be created, and easily same environment we can recreate in our operating systems. Once the image is shared, easily everybody can create the same environment in their system. So they can create same environment without manually setting up each and everything. Now there is one more important difference between image and container which you should know, and that difference is resources. Imagine you are having Netflix account. Okay, this is your Netflix account, and your account itself will not consume any resources. But when you start actual movie, RAM will be used. Okay, any series or any movie, if you are watching in your Netflix account, only then RAM will be used, CPU will be used, as well as internet will be used. But actual Netflix account will not be using any resources. Only when you start or only when you watch the movie, RAM will be used, CPU will be utilized, as well as internet will be used. So it simply means the running processes are consuming resources. So these are the running processes which will be consuming these resources. Exactly the same way, this image is nothing but static. It will only have instructions how the container has to be created. But what is container? Container is nothing but running environment. So here also our image will not be using any resources. Instead, when containers are created from that image, then only resources will be used. And resources like CPU, we will have memory, we will have storage, and all these resources will be used by container. It will not be used by image. That's why Docker images are comparatively very smaller in sizes. But when actual container is created from that Docker image, then our processes will be started, our application will be executed, memory allocation will happen. And that is when actual resources are consumed. In interview, if they ask, you can tell Docker image is nothing but it is static snapshot inside which we will have all the instructions to create container, and container is nothing but it is live running instance, and containers usually runs the processes as well as it is the one who is going to execute our application. I hope you understood what is image. Image is nothing but blueprint, or we can also call it as instruction, or you can call as static snapshot. And what is the container? Container is nothing but actual running application or actual running environment. Docker image is not going to take any storage. Instead, the container which are created from that image, they will be consuming all the resources. And because of this architecture, Docker becomes fast, portable and scalable. Always remember, in Docker, Docker image and Docker container plays a vital role because everything lies around these two things. Till now, we have only understood the theory. Now let us see one practical example so that you will understand real magic of Docker. So in this example, I will be showing you how to create image, and from that image how the container will be created. Now I am having Windows operating system. Now what I want, inside this window, I want to run Ubuntu. So basically, I want complete separate Linux environment. Now the question is, how can we run Linux inside our Windows operating system? Definitely, it is not possible. Why? Because we are not having any dual boot. Without dual boot, we have to run Linux inside Windows. We should not be using any separate laptop, as well as we should not be destroying our system. Without dual boot, without using separate laptop, as well as without destroying our system, we should be running Linux in our Windows. And one more important thing, I want to run Linux in an isolated environment, which basically means my Linux environment should not affect my Windows operating system. So manually, is this possible? Definitely, this is not possible. But with the help of Docker, this is completely possible. And this is where practically we are going to see magic of Docker now. Now I will be showing you one practical example of Docker. We are going to download Ubuntu image, and now you do not have to worry about all this example. I will only show you the magic of Docker. Later on, once we set up and once entire thing is ready, then deeply we will understand Docker as well as its commands. Now what I will do, this is my Windows operating system. Now inside this, I want to run Linux environment. So here we simply have to run this command docker run. Here I will be passing IT, which stands for interactive shell. You do not have to worry. Then which image I want? I want Ubuntu image. I will hit enter. Now you can see first it will tell unable to find Ubuntu image locally. So in my system, I am not having Ubuntu image. So what it will do? It is just going to pull from Docker Hub, and then one by one it will start downloading. Now successfully it has downloaded. So first Ubuntu image will be downloaded. Then from that image our container is already created. Now here you can see the magic. Now I am inside Ubuntu terminal. Before, here I was having users and my name. Now here if you see, I am having root and then I am having this ID. So basically what happened? As soon as we run this command, first Docker will check whatever image we are trying to download locally, if it is present or not. If it is present, they are going to use it directly. If it is not present, then from internet, it is just going to pull that image. And from where that image will be pulled, it will be pulled from Docker Hub. So you can think Docker Hub as a play store for Docker images. Whichever image you want, you can easily come to Docker Hub. From here, you can search for the images and you can easily pull in your operating system. Now here, I will just search for Mongo. hit enter, you can see for Mongo, we will have lot of images. And this is Docker official image. If I just click on this, scroll down here, you will see how to pull Mongo image. So using this, what we have done, we have downloaded Ubuntu as well as we have created container for Ubuntu. Can you see the magic here? Before I was in Windows. Now after pulling this Ubuntu, now I am inside Ubuntu terminal. Now what I will do, I will run this ls. You can see this ls will be working on Ubuntu terminal. It will not be working on Windows. Now as I am inside Ubuntu terminal, successfully this command will be working. And for container, separate environment will be created. It will be completely isolated. So that is the reason I am able to access its file system. So for container, we will have separate file system. So I am able to access that file system. If you want, you can also create the folders here. Let me write mkdir. I will give the folder name as new. Now I will click on ls. Here you can see this folder will also be created. And these files and folders, whatever we create or whatever we delete here, it will only affect our container. It is not going to affect my host machine. So this folder which I have created, it has not created on my Windows machine. It has created inside Ubuntu container. Now, even if I break something or even if I delete the container, doesn't matter. It is not going to affect my Windows operating system. Why? Because our containers are isolated in nature. This is very simple example of Docker. Later on, we will be downloading multiple images from Docker Hub. We will see different commands and lot of other things. We already know this. Whenever we are creating the container will be having its own file system. Container will have its own environment. Okay, basically container will have its own little world. Now inside this container, we can create the folders, we can delete the folders, we can install the packages, and all these changes will only happen inside the container. It is not going to affect our host machine because containers are isolated, and whatever changes we are doing here, entire changes will only affect our container. And this is the exact reason why developers love Docker. Because with Docker, safely they can experiment, they can run different environments because systems are isolated, so they can easily test the application without affecting the actual host machine. So what are the steps we have done? So first, what Docker did? Docker downloaded Ubuntu image. If it is present locally in your system, then from there it is just going to create. If it is not present in your system, then first Docker will be downloading Ubuntu image from Docker Hub. Then next, Docker created Ubuntu container from this Ubuntu image. And inside this container, whichever container Docker has created, inside that we have got complete Linux environment. And this environment is completely isolated from our Windows operating system. Now inside this container, we can run Linux commands. We can use all the Linux tools and we can do Linux specific development. Whatever changes I do inside this container, it is not going to affect my Windows operating system. Even if I delete the container, then also it will not be affecting my original operating system. Everything will be running inside this container itself. Now here, you might have seen an interesting observation. This Docker concept feels somewhat very similar to our virtual machine. And honestly, Docker and virtual machine can feel similar because both are creating isolated environments. But Docker is lightweight, much faster, and it is very easy to set up. And that is why Docker is more popular in modern development. And right now, we only ran Ubuntu container. But Docker is not only limited to Linux. We can also run MySQL containers, MongoDB containers, Node.js containers, Redis.js containers, etc. So using containers, we can create an entire development environment. Now let us finally set up Docker in our system. And after this point, we will download images, we will run containers, we will launch Ubuntu environments, and finally enter the real Docker world. Now let's move to screen. Now finally, we are going to set up Docker in our local machine. First, let me open command prompt, and this installation I will be doing on Windows operating system. Same steps you can follow if you're having Linux or Mac OS. Inside command prompt, I will be writing Docker. As soon as I hit enter, you can see I will have Docker is not recognized as an internal or external command. Why? Because now we are not having Docker set up in our local machine. To set up, we are having few steps. First thing, we are just going to download Docker Desktop. Very important. Second step, we are going to install Docker Desktop. Third, we are going to launch Docker Desktop. And while launching this, our system will restart. Okay, always remember, whenever we are launching, we have to restart our system. Only then our Docker engine will work. And finally, once entire thing is done, we will verify Docker. And what Docker Desktop is? It is nothing but application. Okay, basically we are going to install one application so that we can work with Docker. And what this Docker Desktop will be providing? It will provide Docker engine. Very important. Without engine, we cannot use Docker. It will provide Docker CLI, as well as it is going to give us graphical user interface. Everything inside Docker Desktop itself. Open Chrome and search for Docker Desktop download. Click on this first link. You will be having this page. Now just hover on this download Docker Desktop. You will be having multiple options. If you are using Mac, based on the processor, you can install. For Windows, we are having this based on the processor, you have to install. And for Linux, you have to install this. If you are having Intel or AMD processor, then you have to download this one. If you are having ARM processor, then you have to download this one. I am having Intel, so I will just click on this download for Windows. See, downloading has started. It is around 617 MB. I have already downloaded Docker in my system. So this is the installer. Now I'm just going to double click on this. Downloading is done. Now we are going to proceed to step 2, that is installing. Click on yes. Here you can leave default settings. It is just going to add shortcut to our desktop as well. Click on OK. Now you can see installation process has started, and it will unpack all the necessary files which we require. For Windows, maybe it will take some time, but if you are using Linux, then this process will be very quick. Installation is succeeded. I'm just going to close. Downloading is done. Installation is done. Now we are just going to launch our Docker Desktop. Here, I'm just going to search for Docker Desktop. You will be having this application. Just open this application. Now click on accept. If you want, you can read all the terms. I will click on accept. If you want, you can select personal and you can create the account. But as of now, I'm just going to skip. Now it is going to start our Docker engine. It will take some time, and once our engine is started, you just restart your system. Now I have restarted my system. You should also restart it. Now everything is initialized. Our background services has started, as well as Docker engine has been initialized. Inside this, you can see we are having containers tab and we are having images tab. Whatever images we are going to download, it will be available here. And whatever containers we are going to create from that image, those containers will be available inside this tab. Now once launching is done, I'm just going to open command prompt. Increase the size. Here I will type Docker. As soon as I hit enter, now you can see successfully I am able to get all the commands related to Docker. Okay, this you should get only then it is been verified Docker is set up successfully in our system. Now let us check Docker version. I will write Docker -v. Hit enter. You can see Docker version also you should be getting. Now let me show you one more important website, Docker Hub. I will just click on this first link. Docker Hub is basically like GitHub. In GitHub, what we will do, we will create repositories, we will push our entire code so that we can show it to the world. Similarly, inside Docker Hub, we are just going to store and share our Docker images. So from this Docker Hub, we can download ready-made images for Ubuntu, Node.js, MongoDB, Redis, MySQL, thousands of technologies. So from this Docker Hub, you can download any technology image which you want. Then you can create container from that, and then you can run that separate environment in your system. Very, very important. Later on, we are going to use this website a lot. From your end as well, you can just explore this website. In Docker ecosystem, Docker desktop will be acting as a tool or software, and Docker Hub will be acting as an image marketplace or library where we are going to store our Docker images. And with the help of these two, we can easily create the containers, replicate the environments, isolate our application, and simplify deployment. Understanding Docker theory is very easy, but it will only make sense when we run the containers by ourselves. So now, through real commands, we will understand how to download images, how to create containers, how to start containers, how to stop containers, how to delete containers, etc. So we are going to directly work with MongoDB container, as well as I will show you an example of Ubuntu container as well. In Docker, there are mainly three concepts which you should always remember. First is the Docker image, which is nothing but the blueprint. Second is the container, which is nothing but running environment. And third is the command using which we are going to control our containers. Now, practically, we are going to see some Docker commands. Very, very helpful and very important. If you're learning any programming language, first with what program you will start? Definitely, we will be starting with Hello World. So to understand few of the Docker commands, we are going to pull image for Hello World. So first, what I will do, I will open Docker Hub, and inside this, I will be searching for Hello World. You can see here I am having Hello World. I will just click on this, and this is the Docker official image for Hello World. Just scroll down, and here we are having command to pull this Hello World. As of now, we are not going to worry about all these things. Here, let me write. Whenever we want to pull any image from Docker Hub, we will be using this pull command. Docker pull, and then we will be passing image name. Now our image name is Hello World. So here I will copy this, and inside this I'm just going to paste. Hit enter. It will be using default tag latest. So here tag basically refers to version. Successfully we have pulled Hello World image. Now open Docker desktop. Inside this images tab, you can see Hello World images downloaded. So here what happened when we use this Docker pull Hello World? First it got connected to internet, and then it downloaded image, and after downloading it saved this image in our local machine. And from where we got this image? We got this image from Docker Hub. Okay, these are the steps which happened when we pulled Hello World image. Next command, let me write here. Next command is Docker images. So using this command, we can see all the images available in our system. So here as of now, we have only pulled Hello World. So here if I write Docker images, hit enter, you can see here image name is Hello World colon latest, which basically means it has pulled latest version of Hello World. Then we will have one image ID, how much disk it has used, and what is the content size. Entire details will be displayed. Suppose if I have pulled multiple images, and if I run this command, all the image list will be displayed. Next, after pulling image, what we have to do? We have to create the container from that image. We have already seen image is nothing but static snapshot, and inside this we will have complete instructions to create our container. So now we are having image. Now from this image we are going to create our container. So here image is already downloaded in our local machine. To create our container, actually we are going to run the container. So we will write docker run and then image name. And what is the image name? Image name is nothing but Hello World. Now come here. Let me clear the screen. I will write docker run Hello World. Now you can see hello world. This message shows installation appears to be working correctly. And this is the output it has generated. Okay, you can read this one. But successfully from that image, we are able to create the container for hello world. Now let me open this Docker desktop. I will come to containers tab. Now you can see by default, it is going to give some random container name. We are having container ID, and from which image we have created this container, that image name will be present. And then here we are having some actions. What this docker run command will be doing? First, it will take the image, and then from this image, it is going to create the container. And after that, whatever output we are having, that will be executed, and finally it is just going to exit. So that is the reason we cannot see this container is running. And here if you see, you can see it has stopped, it has exited, because whatever job was done for this container, successfully it has completed its job. But actually whenever we are using this docker run command, it will follow all the steps, as well as it is just going to start our container. Okay, later on we are going to see this as well. But for this hello world, it has given the output and finally it has exited. That is the reason we are not seeing its start status. But later on, when we create another containers, we will see how it will be started using this run command. So basically, using this run command, whatever image we have pulled, we have just given life to that image. Next command, we are having docker ps command. And using this command, we can only see running containers. As of now, no container is running. So here, if I write docker ps, you can see no container will be displayed. But if I want to see all the containers which are running, which are stopped, which are exited, then we have to write docker ps hyphen a. Now you can see the container which we have created from this image, that is exited 6 minutes ago. So here using this command, we can see all the containers. So here we are going to have container ID. Let me decrease the size. Inside this, we will have lot of information. Container ID, from which image, what is the command, when it was created, what is the current status, and name of the container. We are going to get all this information. Now to understand even more, now we are just going to download Ubuntu image. For hello world, what we did, we wrote docker pull and hello world. For pulling Ubuntu, we will write docker pull Ubuntu. So what it will be doing, it will be creating Ubuntu image. Locally, if it is not present, it will be downloading from internet, and then we will be having this Ubuntu image. Then to run container, we will write docker run image name. Our image name is Ubuntu. But for this, I also want access to terminal. So here we will be passing -it. What this will be doing? It is just going to enable interactive mode. So using this, whatever container will be created, it will get access to Ubuntu terminal. Now currently I am on my Windows CMD. As soon as I run this command from CMD, directly I will be going to Ubuntu terminal. Now come here. First, let us pull the image. I will write docker pull Ubuntu. Directly, if you do not want to use this pull command, directly you can run this. First, it will check whether image is present or not. If it is not present, first it will access the image, and then it will be creating and starting the container. Okay, in any which way you can do. Now you can see again it has downloaded latest version, and successfully pull is complete. I will come to Docker desktop, come to images. Now I am having two images. Hello world is still in use, but container has not started. Now I will come here. I will write docker run -it Ubuntu. Directly from Windows CMD, I am able to access my Ubuntu terminal. Now here, if I write ls, successfully for that container, we have got isolated environment. Here I can also create the folders. Let me write docker test, hit enter. Again I will do ls. Here folder will also be created, and this folder will be present inside Ubuntu container itself. It is not going to affect my Windows machine. And here if you want, you can also see all the environmental variables which are present inside the container. These variables are not from my Windows machine. These are the variables from our container. Now come here, come to containers. Now you can see successfully this container has started. So using this run command, our container will also be started. Our container has created and successfully our container has started. And here you can see we are having this symbol, and then you can see here we are having this green color, which means currently this container is running. Now what I just want to exit from this container. For that we are having this exit command. Hit enter. Now again I am back to my Windows CMD. Now I will run this docker ps. As I have exited my container will be stopped, and inside this docker desktop also you can see my container has stopped. From here I'm just going to start the container. Again I will run this docker ps. You can see this command will only show running containers. But here if I write docker ps hyphen a, sorry, it is hyphen a, it will be showing both running containers, stopped containers, exited, entire containers will be shown. Next, we are having start container. For that, I will write docker start and then container ID or container name. We can use anything, container ID or container name. Now what I will do, come to docker desktop. I will stop this. Come here. I will write docker start. Let me come to docker desktop. From here, I will copy this container ID and here I'm just going to paste. Hit enter. This container has started. Now again if I come here, you can see my container has started. If I want to stop, then simple, here docker stop container ID or container name, hit enter. My container has stopped. Come here, you can verify container will be stopped. Now what I just want to delete container. For deleting container, before that let me write, for stopping we are having docker stop and then container ID, or you can also give container name. Next, I just want to delete the container. For that, again we will write docker rm remove container ID, or you can give container name. So come here, here I will write docker rm, then I will pass container ID, hit enter. Come here, you can see the container has deleted. But one more important point you should understand. Let me just create the container again. Docker run interactive mode. I will be writing Ubuntu. So container has created. I will exit from here. Just come to Docker desktop. Here our container has created. Now what I will do, I will just start my container. Now again I will come here. I will write docker rm container ID. Come here, copy this container ID. And inside this I'm just going to paste. Now you can see I will have this error, container is running. So first we have to stop the container and only then we can remove it. To stop the container, I will write docker stop container ID, and then easily I can remove this container. Come to Docker desktop, successfully I am able to remove. Now if I want to remove the images, then for that again docker rm. RM is for removing the container. RMI is for removing the images. I will remove hello world image. Hit enter. Now again you can see I am unable to delete hello world. Why? Because from this image we have created the container. And if we are having any image and from that image if we have created the container, then we cannot delete the image. First we have to delete the container from that. Only then image can be deleted. For Ubuntu, we have created the container, but we have deleted. Now easily we can delete Ubuntu image. So here I will write, first let me clear the screen. I will write docker rmi for removing the image, and my image name is Ubuntu. Now for this no container is there. So successfully we will be able to delete this Ubuntu. Now come to Docker desktop. You can see Ubuntu image is gone. To delete hello world image, first we have to delete the container. So here docker rm, come here, come to containers, copy this container ID, come here, delete it. Now I can easily delete hello world image, docker rmi hello world. Now successfully whatever images and containers we have created, we have deleted from here. So what all commands we have seen? We have seen pull command, using which we are going to download the image. Then we have seen this run command. Using this, we are going to create the container from image. Then using this ps, we are going to see all the running containers. Using this ps-a, we are going to see all the containers, if it is started, stopped, all the containers. Then using this start, we have started our existing container. Using stop, we can stop the container. Using this rm, we can delete container. Using this rmi, we can delete the image. And if any container is already created from the image, directly we cannot delete the image. First we have to delete the container, only then we can delete the image. In larger organization as well, developers manually from starting, they are not going to create entire thing. Instead, they will be creating the containers for MongoDB, MySQL, PostgreSQL, Redis, etc. Which simply means the entire development environment will be running inside the container itself. Till now, we have been running containers, but internally, Docker is having complete life cycle for container. Just like human does. We born, we live, we get stressed, we get unemployed, we do hard work, we get success, failure, and finally death. Similarly, in Docker, container also follows life cycle. And once you understand this life cycle properly, a huge Docker confusion will be cleared. Whatever commands I will be showing you, those commands we have already seen, but let us understand Docker lifecycle. So first what we are doing, we are just going to pull the image, then we will create the container. We can start the container, we can stop the container, as well as we can delete the container. If I take an example of car, so here inside this image, it is nothing but blueprint. Okay, blueprint of car design. Then creating is nothing but manufacturing car. Starting is, we are simply starting engine. Stopping, we are stopping the engine. And finally delete or remove, we are destroying the car or we are just scraping the car. So this is the complete life cycle of Docker. Pulling image, we have already seen Docker pull. Using this, we are just going to pull the image. But for creating container, we have used Docker run. Instead of create, we are passing Docker run, and then we will be passing image name. So basically what this run command will be doing, it will create the container, it will start the container, as well as it will run the container. All these three things one run command is going to do. Directly if we create the container, it is only going to create the container. It will not start and it will not run the container. But directly if we are using this run command, behind the scene, it is going to perform all these three actions. So that is the reason when we use this command, our container was created, our container was started, and our container was also running. But in place of Docker run, if we are using Docker create, and from whichever image we want, we can create the container. In this case, what Docker will be doing? Docker is going to create the container, and Docker will prepare separate file system. Docker will prepare separate environment, as well as Docker will be giving separate setting for this container. So basically, using this create command, we are telling our container exists, but still it is not running. But using run command, all these things will be happening together. So to create and start the container, what command we have to use? We have to use run command. If you only want to create the container, we will be using create command. For example, if you want to create container for Ubuntu, but you do not want to start, you will write docker create Ubuntu. That's it. It will not going to start. It is only going to create the container where Docker will prepare for all these things. Okay. Step 1, we have seen creating. Then step 2. Step 2 is what? We have to start. For starting, we have already seen docker start command, and whatever image we are having, that name we are going to pass. For start, we have already seen the command docker start, and whatever container name or container ID we are having after creating, that we will be passing. So what this start command will be doing, whatever existing container we are having, we are just going to start that existing container. Then next stop, for stop we are having docker stop container ID or container name. And finally, we are having remove or delete. For removing or deleting, what we are having, we have docker. For removing, we are having rm, and then we will pass container ID or container name. And always remember, Docker will not remove the container. First, it will stop it. Only then it will remove the container. Let us write the command. I want to pull Ubuntu image. So we will write Docker pull Ubuntu. Now directly, I want to create the container. So here, Docker create Ubuntu. So container is created. Suppose example, for container, we are having the ID as 123 and container name as ABC. Okay, this container is created. Then next, I want to start the container. So here, I will write docker start 123. You can either use container ID or you can pass container name. I want to stop docker stop ABC. Okay, anything you can give. And finally, you want to delete docker rm123. Unless and until you don't stop, you cannot delete the container. First, you have to stop it. Only then you can delete the container. Okay, this is the complete life cycle of Docker. We can create, and at the end, we can destroy the container as well without affecting our actual host machine. And one more point, Docker containers are not permanent application. We can easily create them, we can stop them, and we can destroy them. And because of this lightweight life cycle, Docker becomes fast, scalable, and developer friendly. Till now, we have learned how to download images, how to create containers, how to delete containers. But in Docker world, there is one more important concept which you should understand, and that is nothing but versions. And honestly, this is where real Docker power begins. Suppose we have one tech company and this company is running three projects, project 1, project 2 and project 3. And this project 1 is using latest version of MySQL. And this project 2 is using, suppose it is using 7th version of MySQL. And this project 3 is using 8th version of MySQL. Definitely, if we are having one host machine, in this host machine, we cannot use all three versions of MySQL. We will have conflict issues. But using Docker, we can easily pull all these images with different versions. So first image will be having latest version, second image will be having version 7, and third image will be having version 8. And from this, we can create the containers, and all these three containers can run on single machine without any conflicting issues. Why? Because in Docker, we do not have to worry about version conflicts. For example, in my host machine, I want to install two different versions of Node. And definitely, this is not possible. But using Docker, as our containers are isolated, we can easily use different versions of Node.js in our same host machine because every version can be used as a separate container. Open Docker Hub. Here I will be searching for MySQL, and here if you just click on this symbol, you will see Docker official image. Just click on this, and here you can see supported tags and respective Docker file links. Inside this, we are having different tags, and here version is nothing but tag and tag is nothing but version. We are having different versions. You can see we are having separate tags version, and inside this you can see all the tags of MySQL. You can see latest we are having 9.7, then again 9.7.0 Oracle. Okay, all the tags whichever we are having, that will be present. Whichever version of MySQL you want, you can easily pull that. For example, if I write docker pull MySQL without specifying anything, it is just going to pull latest image. If I write docker pull MySQL, then I will be passing colon, and whatever version I want to specify, I can easily specify. For example, I will write 9.0. So what it will do, it is just going to pull ninth version of MySQL image. Open command prompt. Here I will pass docker pull. Directly I will be writing MySQL. So you can see default tag is latest, which basically means it is just pulling latest MySQL image. And layer by layer, everything will be downloaded. You do not have to worry about layers. Layers are very important topic, which we are going to see later. But here, if you see, we are able to pull latest version of MySQL. One by one, all the layers will be downloaded. So let us wait for that. So here, one by one, it will extract, and finally, it has completed. I will come to Docker desktop. Successfully, my latest MySQL image is downloaded. Now what I will do, I will write docker pull MySQL colon 9.0. I just want to pull ninth version of MySQL. Hit enter. Again you can see it has started pulling, and if you see here, ninth version is displayed and it is pulling from library MySQL. Okay, ninth version is also downloaded. Now I will be showing you one important concept. Let me just download 8th version 8.0. As I mentioned, layer by layer things will be pulled. So for latest version everything has been pulled, but for 8th version maybe some layers are already present inside ninth or latest version. So here I will be having already exist. Again it is not going to download the common layers. If we are already having, then it is not going to download the common layers. Simply it will mention this layer already exists. Layers we are going to discuss later, but this is how it will work. And that is why Docker is fast, storage efficient and optimized. Now here I'm just going to see all the images. Hit enter. You can see in total I'm having 3 images. One is the latest version, another is version 8 and another is version 9. Inside Docker Hub also I will be having all 3 images. So basically we are having only one technology, MySQL. In this one technology, we can use different versions in one host machine. We are using latest version, ninth version and 8th version. So till now, we have only created images for different versions. Now what we will do, from these images, we are going to create the container. So how we have created, we will write docker run and my image name is MySQL. Okay, this is for latest version. Directly if I run, it will not work. Why? Because for MySQL, let me come to overview. Scroll down. Inside this, you can see we have to add one root password. If we want, we can change the name and we have to run in detached mode. Let us understand one by one. And this is exactly like we are writing colon latest. Okay, by default, it will pull latest. So that is the reason we will not be passing this. This MySQL root password, root password, whatever you want you can give. I will write my name Hanam 123. This is nothing but environmental variable. So to define environmental variable we will write -e. Let me write the command docker run and my image name is MySQL. So here we are creating MySQL container. Along with that we are defining one root password. Next we have to run in detached mode. For that we will be using -d. Normally other containers will be running in attached mode. By default they will be running in attached mode, which simply means our terminal will be connected to the container. Okay, in attached mode, our terminal will be connected to container. But containers like databases, they has to run in the background. So that is the reason we will be passing in detached mode. Okay, it is nothing but detached mode. Simple meaning of detached mode is it is exactly like background apps which are running on our mobile. Exactly in same way, containers will be running in the background and they will be running continuously, and also they are just going to free up the terminal. This is how developers manage MongoDB versions, MySQL versions, Redis versions in real project. They are not going to disturb the terminal. They will be running in the background continuously. So here I will pass -d. Let me pass here. Previously, if we have seen, while creating the containers, we will be getting some random names. Okay, like Crazy Einstein or something like that. So if we want, we can also change the container name. For changing the container name, we will write hyphen name, and whatever name we want, we can pass the container name. Now let us run the container. Come here, clear the screen. I will write docker run environmental variable, all in caps, MySQL. You can refer the documentation as well. Root password is equal to password. I will write Hanam123. Then I have to run in detached mode, -d. I will change the name, hyphen name is equal to, let me give the container name as MySQL latest. And finally, my image name, that is nothing but MySQL. This is for latest version. We are creating the container. So in this way, I will pass. Hit enter. Now you can see container is created. Let me come to Docker. For this image, we are having green color, which means this is in running state. Come to container. Whatever name I have given, that name is present. From which image I have created the container, that image name is present. And whatever container ID is created, that container ID is also present. Now for MySQL 8, I'm just going to do. So here I will pass 8.0. I will change the name. I will write MySQL version 8. Rest entire thing is same. And for this also, I will give the same password. Hit enter. Second container is created. Come here. You can see MySQL version. And now what is the image? Image is nothing but version 8. Here successfully you can see all the latest version, and from which image these containers are created, that will also be present. Similar way I can also create for version 9. I can change the name. I will write version 9. Hit enter. Successfully containers are created for different images. Now in total I have created 3 containers and I am having different version of images, and all these containers I am using in single machine without any conflicts. You can see I will just write here docker ps. Each and every container is running without any conflicting issues. What this docker ps will be returning? It will be returning all the running containers. So successfully inside each container we are having different MySQL version environment, and successfully we are able to run in single host machine. So to summarize, what are tags? Tags are nothing but versions. To define environmental variable, we will use -e. For MySQL, we are going to define the password as well. For changing the name, we will write -name. And if we are having any databases, we are going to run in detached mode, because we don't have to connect to terminal. We have to run that in background. So that is the reason we will be running in detached mode. Till now, we have completely understood about images and containers. We have explored containers as well as we have run Ubuntu in our Windows operating system. But now, an important question arrives. What is the difference between Docker and virtual machine? Because both are providing isolated environment, run applications, and both feels like separate systems. So for beginners, both might look similar, but internally, the way both works is completely different. First, let us understand how our computer work. This machine can either be Windows, it can be Linux, or it can be Mac OS. Doesn't matter which machine we are using, we are going to have 3 layers. First, we will have hardware. On top of that, we are going to have operating system kernel. And on top of this, we will have applications. So hardware is nothing but it is physical part of the machine, like CPU, we can have RAM, we can have keyboard, okay, basically physical part of the machine. Then next we are having this host OS kernel, and this is nothing but brain of the operating system. It is going to manage memory, it will allocate CPU for us, it will control our applications, as well as it is going to communicate with our hardware. It is just going to communicate with hardware. So what is hardware? It is nothing but physical part, and OS is nothing but brain of our operating system, which is going to manage memory, allocate CPU, communicate with the hardware, as well as control applications. For example, now I'm just going to open Chrome, and Chrome needs some RAM. And what is Chrome here? Chrome is nothing but our actual application which is running on our system. So Chrome directly, it is not going to take the RAM. What it will be doing? It is just going to make the request to kernel. And then this kernel will be allocating RAM for Chrome. Similarly, our file access, CPU usage, processors, everything will be handled by OS kernel. And last, we are having application. Application is nothing but like we are having Chrome, we have VS Code editor, we are having Node.js apps. So whatever application we are having in our system, those will be present inside this layer. Whatever application we use daily, that we are going to have in this layer. Doesn't matter which host machine we are having, we will have all these three layers. So we are having hardware, then on top of that, we are having operating system kernel, and then we are having application. So what Docker will be doing, Docker is going to isolate only this application layer. Suppose this is my Windows operating system, and inside this I'm having one container. So here we are running something. So what Docker will be doing, it is only going to isolate the application, but Docker is going to use the same kernel of Windows operating system and same hardware resources of Windows operating system. So here our applications will be running in this environment, but they will be using same OS kernel and same hardware. Whatever applications, dependencies or libraries we are having, only that will be isolated. But when we talk about virtual machine, it is going to virtualize our entire operating system. Suppose I am having Linux operating system, and inside this I am creating one virtual machine. So this virtual machine will be having its own kernel, they will have its own operating system, as well as they will have its own application. So the major difference between Docker and virtual machine is which layer they virtualize. Basically, which layer they are created. Okay, let us take one simple analogy. First, let us understand about Docker. Docker is like inside building, we are having different rooms. Each room is isolated and they can have their own setup, but they will be using same electricity of the building. They will use same water system and they are inside one same building. But when we talk about virtual machine, it is like separate house. They will be having their own setup. They are going to use their own electricity, own water system, and they will be having their own foundation. So that is the reason VMs are heavier than Docker, and Docker is lightweight because of this setup. And why it is lightweight? Because they are using the host kernel. They are not creating their own kernel. Instead, they are using the host kernel. So that is the reason Docker will be using less RAM, and we can easily set up Docker, as well as it is smaller in size. And why virtual machines are heavier? Because they will run their complete operating system, which means inside Windows operating system, I can run Linux system. And inside this Linux system, I will have its own kernel, I will have its own drivers, services, background processes, everything runs separately. That is why VM requires more RAM, they require more CPU, as well as they require more storage. Originally, Docker was built for Linux. So even today, most of the images which you will be finding are Linux based. This is very interesting part. If Docker needs Linux kernel, then how Docker is working on Windows or Mac operating system? This is where Docker desktop helps. Internally, Docker desktop will be running lightweight Linux virtual machine. And inside that Linux environment, Docker run containers. So this really does not mean you cannot run Docker on Windows or Mac OS. Till now, I have used Windows operating system and successfully we were able to run each and every Docker command. If you're learning, Windows is perfectly fine. If you're having Linux, Mac OS, Windows, it doesn't matter. For learning, you can use any operating system. And if you're building any personal project, then also it is completely fine. You can use any operating system. Docker will be running perfectly fine. I hope difference between Docker and virtual machine is clear. Successfully, we have completed phase 1. Inside this, we have understood what is Docker, what are Docker images, what are Docker containers. We have seen popular commands. We have seen difference between Docker and virtual machine. We have seen complete life cycle of Docker, as well as we have understood how different versions are used in system. Just practice this phase 1. Only if you completely understand phase 1, move to phase 2. Let us proceed with phase 2. In this, we are going to learn most important concepts in Docker. We will understand what is code binding. We will understand the concept of Docker networking, how containers can communicate with each other. Each and every important topic we are going to cover in phase 2. To understand all this important concept, we are going to see the most common use case of Docker by building application using Docker. For that, we are going to create one simple Node.js application. Complete source code link you will be finding in description. You can open the link and you can download the source code. Once you download the code, right click on this and extract complete folder. I will open this folder, right click and open with code. So we are going to create simple to-do list application using which we will understand more about Docker. I am having app.js inside which we have started the server. We are having one route to create the task. We are having one route to get the task, and also we have connected to database. Later on we will uncomment and we will understand this one. But as of now we have connected to database. Inside public folder, I'm having index.html and style.css. This is very basic to-do list application, so you do not have to worry about the entire code. What we have done inside this app.js, we have written all the routes, we have served our front-end files, and we have started the server. Inside this model, we have created our task schema. But first, let us set up our project. Here, I'm just going to install some packages. npm install. I need Express, I need Mongoose, as well as I need Node.js. Hit enter. All the packages are installed successfully. Open package.json file. Inside these dependencies, you can see all the packages. First, inside this type, I will be changing it to module. Inside this script tag, remove this entire thing. Here, I will be passing start. Here, I will write node app.js. Inside app.js, we have written the code to start a server. So I will be passing app.js. Next, I will be creating dev. Inside this, I will write nodemon app.js. Now open terminal. I will start the server npm run dev. Now nodemon has started. Our server is running on port 3000. I will open browser localhost 3000. This is our simple to-do list application. Now currently what we are having? We are having simple app.js which will be acting as a backend. Inside which we have started the server. We have connected to database. If you want, you can create separate files. And also we have passed different routes for creating the task as well as getting all the tasks. Then inside public folder, we are having simple index.html file, and also we are having CSS file where we have added some basic styling. In place of this, if you want to give complete React application which you want to build using Vite, then also you can proceed, because whatever steps and whatever concepts we are going to learn, that will remain same. Doesn't matter what node application or doesn't matter what technology you are using, concept remains same. Now inside our code, if you see, we have added the route and we have connected to database. But internally, we have not installed MongoDB in our system. And MongoDB is the database which we are going to use in this project. So for this, what we will do, we are just going to download Mongo image. And for this, we are going to create the container. Instead of installing MongoDB locally, what we will do, for MongoDB, we are going to create Docker container, which simply means our Node.js application will be connecting to the MongoDB database, which is running inside the container. Inside these containers, we are going to store the data. We can easily fetch the data and we can perform all the database operation like deleting, updating. We can perform every single operation. Whatever node application we have created locally, we have not installed any database in our system. So for that, we are going to use our Mongo image. And from this image, we will be creating container. And what our node application will be doing, it is just going to connect to MongoDB database, which will be running inside container. And how this container is created, we will create container from this Mongo image. So inside this container itself, we are going to store our data. We will fetch complete data so that whenever we get all the tasks, we can fetch complete information and we can easily perform all database operations. If you want to perform, you can also perform CRUD. So to achieve all this, what all images we need Mongo image, using which we are just going to connect to our MongoDB database. Next, we need Mongo Express image. And this is nothing but admin interface, or you can also tell it is web-based UI for MongoDB. So using this Mongo Express, we are just going to connect to our MongoDB database. Basically, it is like graphical user interface. In browser, we can see complete thing, and in browser itself, we can perform operations like creating database, adding the collection, adding the document, entire thing. So we are going to pull both the images and then we are going to create containers for these images. Then what we will do, we will connect our Node.js application so that everything will be working together with Docker. Before pulling these images, we are going to talk about one important concept, that is port binding. We will go very slow because this is one of the most important concept in Docker. First, let me open command prompt. Inside this, I'm just going to run docker ps. In phase 1, we have created 3 MySQL containers for different versions. And if you see, for each and every MySQL container, we are having port. And here, by looking at this, you can tell for every container, we are having the same port attached to it. But actually, behind the scene, it works completely different. Whenever we are creating container, we have already seen containers are isolated and we will have its own file system. Each and every container will be having its own file system. Similar way, each and every container will be having its own ports associated with them. Suppose this is my container 1, this is my container 2. For this, they will have separate ports, and for this also, they will be having separate ports. Both ports are not connected, they will be having separate port system. So here, if you see, for MySQL, by default, we are going to have this 3360. So which basically means for this container 1, whatever port we are having, inside this MySQL is attached. For another container, again we can have this 3306 port. For this, another MySQL version is attached. Same ports are not attached for those containers. I hope this confusion is cleared. Why I am saying this? Because in our host machine also, we will be having ports. To see all the ports, let me just write this netstat -ano, hit enter. You can see I am having lot of ports in my host machine. Currently, our project is running on 3000. So here, somewhere we will be having 3000 as well. You can see 3000, it is listening. Again, if I run the same project and if I use 3000, I will have this port is already in use. Please use another port. So let me come here. So I am having host machine. In our host machine also, we can have different ports. Here I will be passing 8000. For example, I will be passing 3000. Then I am having container. Inside this, we are having MySQL container, which is connected for 3306. Another MySQL for different version, which is connected for this port. Another MySQL for another version. This is connected for this port. So it might look all ports are connected to each other, but as I mentioned, for each and every container, we will have separate ports. So individually, inside that container's port, they are connected. And always remember, whatever ports we are having here, these are not ports of our host machine. These are the ports of the containers itself. But what we just want to bind our host machine port and container port, which means whenever I'm sending request to this 8000, let me write here, whenever I'm sending request to this 8000, which is nothing but port of our host machine, the request has to be transferred to our container port number 3306, and this is container port. Okay, whenever I'm sending any request to this host machine port, the request has to transfer to this port which is present in our container. For that, we will be using -p command. So basically, what we are doing, we are just mapping our host machine port with our containers port. And this process of binding or mapping is called as port binding. Okay, whenever we are mapping host machine port with our container port, this process is called as port binding. And this mapping is very, very important. Now let us understand why this mapping is important. This is my host machine. Inside this host machine, I have created one container. And then what I have done, I am just running my container. Inside this container, we can have some applications. So running container, most of the students get confused here. Running container is not equal to accessing the application which are present inside the container. I hope this is clear. Running container is not equal to accessing its application. Simply we have created the container in our laptop, but whatever applications we are having inside the container, we cannot access that even if our container is running inside our application. So now our container is running, okay, whatever container we have created, our container is running, and inside that whatever applications we are having, those are live. But we are outside, we are having this laptop, and inside laptop also we will be having some application. Let us take the example of browser. So from our laptop browser, we cannot directly access the application which are present inside our container. Even if it is live, we still cannot access those applications. So here our Node.js, where it is running on port 3000. And inside the container, we will be creating MongoDB. And for that MongoDB, by default, we will be having this port. Okay, this port number we have also attached in our code. You can see inside app.js, here we have passed the port. So in our laptop, our Node.js is running on 3000, and inside container, our MongoDB will be having this port. Without port binding, we cannot see anything inside the container from our laptop. But using this port binding, what we are doing, we are just connecting this container's internal port to our laptop's port, so that easily we can transfer all the requests to container port and easily we can access the applications. Now let us see the syntax of port binding. We will write -p, then we are going to pass the host port, whatever port we want to assign, we can give, and then we are going to pass container port. Okay, for containers, we will be having some default port associated with that. Accordingly, that port we are going to pass here. For example, for MySQL, if I just want to do port binding, then what we will do, -p host port, I will be passing 8000. Then what was the container port? 3306. And then we will be passing the image name. So with this, what we are saying, port 8000 of the host machine will be mapped to MySQL port 3306 inside container. So whatever request we are sending here, that request will be transferred to this port. Previously, in phase 1, whatever containers we have created, those were not binded to any host machine. So first, let me see all the containers, Docker PS, all three containers are running. So now I'm just going to remove those containers. Docker RM, come here. From here also directly you can remove, but let me just copy this. But before that, we have to stop the container. Docker stop, paste, hit enter. Then Docker RM, paste, hit enter. This container has deleted. Let me check. Hit enter. Now I am having only two containers. Now remaining from here itself, I'm just going to delete this, and also I'm just going to delete. But inside images tab, we are having this three images. What I will do, ninth version, I'm just going to delete. As of now, let us work on these two images. Now let us see all the images, Docker images. As of now, I am only having two images, latest version and 8th version of MySQL. Now using port binding, we are going to create the container. So here I will write docker run databases. We are going to run in detached mode. For MySQL, we have to pass one environmental variable. MySQL root password is equal to, I will write Khanam 123. Then I want to change the name as well. Hyphen name. Name I will be passing MySQL latest. Then port binding hyphen P, host machine 8000. We are just going to map with container port 3360. Then I will be passing my image name MySQL. Hit enter. Container has created. Now I will run docker ps. Hit enter. Now if you see, let me just decrease the size. Our host machine 8000 is mapped to container port 3306. Successfully, we are able to do port binding. So whatever request we are going to get from this 8000, easily we can transfer the request to this port. But now I will be showing you one more interesting thing. I will write MySQL 8th version. Come here. I will be using the same host port number. Here I will write MySQL version 8. Rest entire thing is same. As soon as I hit enter, I will be having this error bind for 8000 field. Why? Because in our host machine, this 8000 is already allocated. So again, same port we cannot use for another container. If you just want to check, again you can run this command, hit enter. Somewhere you will be having 8000 which will be listening on this host machine. You can see 8000 which is listening. So that is the reason again we will not be able to use. So what I will do, I will be using another port. Let me write 8080. But here if you see container has already created, let me just come here. But for this container, we are not having any port assigned. So what I will do, I'm just going to delete this. Here inside this, again, I'm just going to run the same command. Now successfully container has created. Come here. Now you can see different host machine port. Successfully, I am able to connect with this port. I hope this concept is clear why we are using this port binding. But in our project, as I mentioned, we will be using two images, Mongo image and we will use Mongo Express image. Now for Mongo, by default, we are going to have this port number 27017. So what I will do, whenever I am doing port binding, I will write hyphen P. For host machine also, I will be passing the same port. If you want, you can change the port. Then whatever Mongo port I am having, that I will be passing. In this way, I will do port binding. Here, let us use the port 8081, port binding 8081 colon 8081. So in this way, for both Mongo and Mongo Express, we are going to do port binding. So whenever we are having any request on this port, easily that request will be passed to the container. Here also, whenever we are having request to this port, easily that request will be passed to this port inside the container. So port binding is very important concept in Docker. Next, let me open Docker Hub. Here, I will be searching for Mongo image. Click on this Docker official image, scroll down, and inside this you can see we are having two environmental variables, Mongo initdb root username, Mongo initdb root password. So both I'm just going to copy, come here, and inside this I will be pasting. Whenever we are running container for Mongo and Mongo Express, all these things we require. So for environmental variables, what we will use hyphen E. Next, let us see image for Mongo Express. For Mongo Express, we are going to pass three environmental variables. One is this one, meconfig mongodb URL. I think in official image, this is not yet updated, but from here, I'm just going to copy that. Let me just paste it here. It should be visible. Here we are passing MongoDB. This will be username and this will be password. In our project, username, I will write Khanam123. Password, I will pass secret. Same username, I will pass here, Khanam123. Password, I will be passing secret. Then we are having our Mongo. Okay, for this, whenever we are running container, we will be giving the name as Mongo. So that name we are going to pass, and that port number, whatever port we are having for this container, that port we are going to pass. Again, come to Docker Hub. Now I will be searching for Mongo Express. Click on this. Scroll down. For Mongo admin username and password, we are having these two environmental variables. So same thing, we are just going to copy, and inside this I'm just going to paste. This will be Hanam123. Below this I will be writing password. Password will be secret. Okay. Using port binding, we are just mapping host machine port and container port. And whenever we are running container for Mongo and Mongo Express, we are having some environmental variables, very, very important, using which we are going to define our username, password, MongoDB URL, etc. And whenever we are passing environmental variable, we are just going to define with -e. Doesn't matter how many environmental variables we are having, that many times we will be writing -e. Now the question is, what are environmental variables? So these are nothing but these are some external values which will be given to our application while it is running. Okay, these are some external values which will be given to our application while it is running. Instead of hard coding any values, we can easily give environmental variables. In our project also, now let me come here. We are passing this username and password. So what I will do, now I'm just going to comment this. I will simply uncomment this one. Now directly you can see I have hard coded my username and password. At this point, what you can do, you can create one env file. Inside that, you can pass all the environmental variables. And later on, you can simply access those environmental variables without hard coding here. But for learning purpose, this is fine. So what all we have seen, it will be running in detached mode. We can easily change the name. We will be passing environmental variables. We have done port binding. Still, we cannot execute this command or run the containers for Mongo and Mongo Express. Why? Because we have to understand about Docker networking. Again, one of important concept in Docker. Let us go little back. We have created containers. Until now, what we know, containers are isolated. Containers will be having their own file system, as well as containers have their own codes. If I am having two containers, both containers are isolated. So now the question is, if containers are isolated, then how they communicate with each other? Because we will create front-end container, backend container, Mongo container. So our front-end should be talking to backend. Our backend should be talking to Mongo container. So how does communication happens? Now Docker networking comes into picture. These containers cannot talk with each other without accessing each other's port. But when we are setting up Mongo and Mongo Express for a Node.js application, what we want, these containers should be communicating without any limitation or without depending on any ports. So for that, we are going to use something called as Docker network. So Docker network is basically a communication system between containers, or simply you can mention it is private network inside Docker. Imagine I have created two containers in my host machine, and whenever we are creating any container inside the host machine, by default this container will be having some default networking already enabled in it. For example, if I create this container one, by default it will be having some networking which is enabled, and for this container 2 also, by default, we will be having some network. But using Docker networking, what we will do, we will be creating our own isolated network, and inside this network, we will be passing both these containers. Now easily inside this network, both these containers can communicate. They don't need any port, they don't need any local host, they don't need any binding, they don't need anything. Using this network itself, both containers can communicate. Again, let me tell you, whenever we are creating container, by default, they will be having some networking already enabled with it. But using Docker, we can create some isolated network, and inside this isolated network, we are going to pass our containers. So now Both these containers can communicate with each other without any local host or without any ports. Let us understand using one simple analogy. You are living in one society, and this society is called as Docker network. And inside this, we are having some houses, okay, houses or flats, and these are called as containers. And whenever person is talking, this is like communication between them. So now we are having two containers, basically two houses, house A and house B. This is our Node.js container and this is our MongoDB container. If both houses are in same society, the person inside those houses can easily talk. But if the houses are in different society, then persons cannot talk with each other. If they are in same society, then easily they can talk. If they are in different society, then they cannot talk. Exactly the same way, using Docker, we will be creating our private network. Inside that, we will pass the container so that communication happens easily. Docker networking is all about how containers are going to interact with outer world and how incoming and outgoing connections are formed. One more important point you should understand, if we are having two containers, containers can talk using container name. Okay, we will be passing some container name. So containers will communicate using container name. It is exactly like if you're having your friend number, this number you will be saving with the name. Definitely, nobody will be remembering the number, but if you search Rahul, you will be having this number. Similarly, whenever we are giving some container name, using this container name, communication happens. By default, internally or backend, these containers will be having some IP. We don't have to remember that IP, but using this container name, we can easily communicate. Now to see all the networks, let me open CMD, increase the size. Here I will write Docker network ls, hit enter. By default, I will be having three networks and every network will be having its own individual ID. You can see by default, we have bridge network, host network and none. And we are having some drivers and whatever scope it is having, that scope will be present. So Docker mainly gives default network. We will be having some default network. As I mentioned, whenever container is created, by default, we will have some networking enabled with it. Second is custom network. Okay, this is the private network which we are going to create in our projects. And we are also having drivers which we have seen. Let me show you. And these are the drivers which we are going to see later. Okay, as of now, we are not going to talk about drivers. We are only going to focus on this default and custom network. Whenever we are creating Docker container, it will be connecting to default network. Example of default networking, I'm just going to run Mongo container. Okay, simple example. I will change the name. Name I will be passing Mongo. Image name I will be passing Mongo. So here doesn't matter what container I am creating, by default they are going to enter one bridge network. So it is like Docker automatically it is going to create one society or apartment. Now whatever new container we are going to create, by default they are going to enter into same society. Unless and until we create our own private network and define those containers inside this network, every new container will be entering inside this default society which will be having this bridge network. Problem with default network is technically containers can communicate but they are not very well organized, very much harder in real project and it is less controlled. So in real projects what we will do, we will be creating custom networks. So what is custom network? Custom network is created by developers using which we can organize our containers, isolate projects and improve communication. Now let us create Docker network. Docker network create. We will use this create command. Network name you can give anything. I will pass my network, my new network, my custom network, my private network. You can give any name. Hit enter. Now I'm just going to run Docker network ls. Hit enter. You can see my custom or private network is created and the name which I have given is my network. And by default, whenever we are creating our custom network, the driver type is nothing but bridge. So basically, here what we have done, we have created one new society. By ourselves, we have created previously Docker. By default, it will be creating one society or apartment. But now using create command, we have created our own society. So now here I am having one container. I have created another container and both the containers will be attached to this bridge driver. By default, we have created this new society, new network, and inside this network, whenever we are creating container, by default, these containers will be attached to bridge drivers. Now, these containers can easily interact with the outside world as well as they can interact with our host machine using this bridge driver. Now, definitely one question should arise whenever we are creating any container. By default, they will have bridge network, and whenever we are creating custom network as well, then also by default they are having bridge network. So using bridge network, they can easily communicate with each other. Then why do we need to create our custom network? Because of some reasons. First is better container name. So if container 1 wants to communicate with container 2 directly without using any IP address, they can communicate with the name. We will be giving the custom name. Using this name itself, directly they can communicate. So what Docker will be giving? Docker will be giving this default society where our containers will live. But for our own project, we are going to create our private society, which is nothing but our custom network, so that only our project network will be living inside this society and they can communicate with each other. So second reason of using this custom network is isolation. Whatever containers we are having which are not communicating, they can be in the default network. But for our project, we will be creating custom network, and inside this we will be creating containers so that they can communicate with each other. So how we are going to connect containers? Whenever we want to specify any network, we will be using this hyphen hyphen network command. So basically what we want, we will be creating Mongo container and Mongo Express container, and both the container has to interact in the same host machine, and for that by default we will use bridge network driver, and to specify that same network we will be using this hyphen hyphen network command. And what custom network we have created? We have created my network. So inside this my network, I'm just going to put both my Mongo container and Mongo Express container. Now let us finally create and run our Mongo and Mongo Express containers. First, I will open Docker. Now here, I do not need this MySQL. I'm just going to remove. First, I will stop. You can also delete from terminal. Then come to images. From here also, I'm just going to delete. Now we are not having any images. We are not having any containers. Let me clear the screen. My network name is my network. Till now, whatever we have learned, using all that, we are going to run our Mongo and Mongo Express container. Docker run. We have to run in detached mode. I will come to next line. For that, I will be using this caret symbol. If you are using Linux, then you have to use slash. I will do port binding. Host port 27017 colon container port 27017. Give one space, caret symbol. I will give custom name hyphen hyphen name. Name I will be passing Mongo. Next, I will give the network. How we are going to specify network? Using this network command. What network we have created? We have created my network. Next, we have to specify environmental variables. Here I will pass Mongo init db root username. Username I will write Hanam123. Then again environmental variable I will pass Mongo init db root password. Password I will pass secret. And whenever you are passing password or username after equal to or before equal to, you don't have to specify any space. Then finally I will pass the image name Mongo. Hit enter. Now you can see Mongo image is not present. So first it will pull and one by one, all the layers will be downloaded. Very important, whatever concepts we have learned till now, using all those concepts, we are going to create Mongo container. Code binding is done, custom name, we have specified which network this container has to be created. Then we have specified username and password. And this exact username and password, we are going to pass inside our app.js. And this custom name, what we are giving, this is nothing but the host name using which our Mongo Express is going to communicate with this Mongo container. Let us wait for the downloading part. Successfully, image is downloaded. Docker PS, you can see our host port is mapped to our container port. You can see all the details, container ID, what is the image name, status, we are having this ports, as well as what custom name we have given, that is also present. Similar way, before that, let me open this Docker. Here we are having Mongo container and also images present. Next, we are just going to run our Mongo Express. Docker run -d caret symbol code binding 8081 colon 8081 caret. I will specify the name. Name I will pass Mongo Express. Then specify the network. Which network we have to create? We have to create inside my network. Then as I mentioned, we have to pass these three environmental variables. Let me just scroll up. For Mongo Express, we have to pass all these three environmental variables. Let me just copy this first one. Come here. For environmental variables, I will write -e, paste this complete thing, caret symbol. Again come here, copy, admin password. Whatever username and password we have given for Mongo, same thing we will be passing here. Again caret symbol, bring this down. Next, we are just going to pass this Mongo URL. I will copy. Come here, environmental variable, paste. So inside this, we are having MongoDB. Then whatever username and password we are having, that I will pass at Mongo. What custom name we have given for our Mongo image, that I will be passing. If you have given Mongo 123, accordingly, that name you have to pass. And what port we are having for our container, that port I will be passing. And lastly, I will be passing my image name. My image name is Mongo Express. Hit enter. Okay, here I am having one error because here while passing this environmental variable, in place of equal to, I have passed this colon. Now I have just changed to equal to. Hit enter. You can see again Mongo Express locally it is not present. So first it is going to pull the image and one by one all the layers will be downloaded. Only thing is, I have just changed from colon to equal to. Successfully, our containers are created and also images are present. Now let us finally see if it is working or not. Locally, we have not created any database. First, I will start the server, npm run dev, hit enter. Open this Docker. First, we have to access this Mongo Express, which is nothing but graphical user interface, and this is running on port 8081. Directly you can click on this. You can see if you are getting this sign in, okay, in browser, you have to pass 8081. Whatever port you have passed while binding, okay, let me show you. Whatever port you have passed while binding, that port number you have to pass. If you are getting this sign in option, successfully Mongo Express is set up. So here you have to give different username and password. Our username is admin and password is pass. Successfully, you can see Mongo Express interface is displayed. Now in our code, let me just come here. We have created the database to do app. I'm just going to create the same database. So this is the graphical user interface. By default, we are having these three databases. Now here, I will pass to do app. Click on create database. Click on this database. Inside this, we can create the collection. Collection name, I will be passing task. Click on create collection. Here we can add new document. Inside this model, let me show you. Inside this task.js, we have only pass title which is of type string. So below this, here I will be passing title colon title. Let me write record videos, and then I'm just going to save the document. Inside this to-do database, inside this collection, I have created one document. Now what I will do, I'm just going to open this localhost 3000. Our project is running on 3000. And then what I will do, I'm just going to access all the tasks. For that, we have given the route as task. You can see successfully we are able to access this complete information. This information I have added inside this Mongo Express, but my project is running on 3000. And if I access this get task, let me come here. For getting the task, I have passed this route successfully. Whatever task I have created here, I am able to access. So clearly, you can understand this difference. MongoDB, it is running inside our Mongo container. This is our actual database. And Mongo expresses graphical user interface where we can perform all the database operation like viewing database, managing the database, etc. If we are not giving this port binding or if we are not specifying this network, our project will not run and we will not be able to access all the tasks. You can see 8081 we are able to access, and from our project we are able to access this task. Locally, we have not done any installation. We have created containers and our Node.js application is interacting with these two containers. So what we have done, this is our complete Node.js application. Inside this, we are having one app.js, inside which we have written complete server code. Okay, basically we have written backend code. For database, what we have done, we have created one Mongo container. For graphical user interface, we have created Mongo Express container. And this is nothing but our Docker environment. This is our node application which is present inside our laptop and inside host machine. Okay, in Docker environment, we have created these two containers. So here we are having a database. Whenever we are sending any data, that data will be stored inside this database. If you want to fetch the data, we can easily fetch the data and show it on the screen. And whatever changes we are doing, all the changes we can see inside this Mongo Express. And how these changes are visible? Because both the containers are present inside the same network. So that is the reason they are able to interact with each other, and whatever changes is happening to database, all the changes we can see inside this graphical user interface. So doesn't matter what application you are using, let it be Node.js application, let it be Python, JavaScript, let it be any application, for all that Docker images are already available. So you can use Docker images for all those technologies and create containers out of it. You do not have to install all the technologies in your system. Directly you can use Docker images, create containers, and how we have specified this exact same way you can do port binding, you can specify network, easily communicate with containers and run those technologies in your local machine. Now let me show you one more important thing. Localhost, I will only pass 3000. Hit enter. You can see here in my UI also, whatever data I have passed here, I am able to see that data in my UI. Next, I will be passing eat apple. Click on this add task. Eat apple is added. Come here, refresh once. You can see now that data is also present inside Mongo Express also. If I refresh successfully, I am able to get all the data. So our node application is interacting with our database, and whatever changes we are doing successfully, all the changes we are going to see inside this Mongo Express. If you have got the output, mention in comment section you have got the output and successfully you are able to add the task. Let us talk about three different network drivers which are supported in Docker. Think of them as different styles of networking. So main ones are, we have bridge driver, host driver and none driver. When we did Docker network ls, by default we will be having three networks. We are also having drivers. First is bridge driver, second is host driver, and third is none. None or null, you can call anything. Whenever we are creating a new network, by default this will be bridge network. And what is this? This is Docker's default networking mode. Okay, we have already seen. So what is bridge? In Docker, this is the default networking mode. So here in this bridge network, when containers are created, they will be having their private IP address. They will have ability to communicate and they are just going to isolate the network. Default one, whenever we are doing Docker network ls, by default we will have one bridge network. But whenever we are creating custom network, then also by default it will be in bridge network. So whenever we are creating something, this is called as customization, or we can tell this is custom network which we have created. So whenever we are creating any custom network, then also by default it is going to adapt bridge network. So in this node application, what we have created our Mongo container and we are creating our Mongo Express container. And to communicate each other, both should be attached to one bridge. So for this, we have created one isolated network so that easily they can communicate with each other. So whenever we are creating network, the basic difference is we can easily communicate using container name. But now, if I come here in my application, I am using localhost. Why? Because our Node.js application is running on Windows. But later on, if we make our Node application as container, then in place of localhost, we can pass the container name and easily they can communicate with each other because all the three containers will be lying in the same network. Mongo container, Mongo Express container, and Node.js application. So whenever we are passing this Mongo container name, what Docker will be doing? Automatically, it is going to convert container name into its IP address. That is the reason we will be able to connect. Second type we are having is host network. If we are using host network, in that case, if we are creating container, then this container will not get separate network. Instead, what this container will be doing, they are going to use network of our host machine. For this container, we are not going to get the separate network. So whatever network and ports we are having for this host machine, that will be used inside this container. Okay, in this network, this container uses the same network as the host machine, and because of this, this container does not get its own IP address. Example, here I will write docker run. I will be passing this network option. I'm just going to specify this network host. You can see in this way, we are going to specify host network and then you can pass any image name. Now what this container, whatever container will be created, this container is directly going to use our laptop's port. So in this case, usually port binding is not required. Why? Because directly they will be using laptop's port. So no need of port binding. Port binding, deeply we have understood why we are using and purpose of port binding. So we are having some limitations or you can tell some disadvantages, less isolation. Both will be using same network and ports. So we will have less isolation and our container is directly accessing machine network. So definitely this will be less secure. So using host network is very rare for beginners. Most of the time we will not be using this. But if you are using any high performance application, in that case you can use host network. Mostly this is used in Linux servers. Then third type we are having none or null network. By the name itself you can understand whatever container we are creating, they will not have access to internet, they will not be able to communication, okay, no communication possible, and they will not be having any access to network. So this will be completely isolated. You can just imagine this like an isolated island where we don't have any roads, no internet and no communication. How this we are going to create? We will write docker run specify network. What network? None network, and we will be passing image name. So whatever container is created, they will not have access to internet. So definitely they cannot ping anything. Of course, communication is not possible. So when this none network is used, if you want any security sensitive environment, in that case, this network is widely used. Or if you want to test any isolated apps, in that case also, this network is widely used. In real projects, what all we will have? We will have React for front end, then we will have Node for backend. Okay, you can assume of any technology, then we will have MongoDB for database. Everything should be connected using custom network. And what this whenever we are creating custom network, in which network it is going to lie? It is going to lie on bridge network. So these custom networks are widely used because they are safe, they are clean and scalable. Networking and code binding is very important. Take your time to understand this concept. Once you completely understand this phase 2, only then proceed with phase 3. Successfully, we have completed phase 2. We have seen code binding. We have seen what all environmental variables we will be using. And most important topic, we have understood about Docker network. Let us now start with phase 3. In this also, we will understand some of the important concepts, okay, which you will be using all the time. First is Docker Compose and second is Docker Volumes. Let's start with Docker Compose. In our application, whenever we want to run multiple containers, what Docker Compose will be doing? It will be providing us easy way to manage and run those containers. Okay, we have seen Mongo container, we have set up Mongo Express container, and we have not seen any major issue. But using Docker Compose, same process we can do in easy steps and it will be very helpful for developers. Till now, manually we were running containers and whatever commands we were passing, all the commands with all the options we have passed inside the terminal. For example, if I consider Mongo container, here we have done code binding, then we are passing custom name, we are defining the network as well as we are passing environmental variables. All the options we are passing inside the terminal. But this is not the end of options. In real world, there can be many options. For example, if I'm having 5 containers, then each and every time I have to define environmental variables for all those containers. For Mongo, if I'm creating these 5 containers, then for each and every one, we are going to specify 2 environmental variables. So in total, 10 variables we have to define. Then we have to pass custom networking. We have to do port binding. For every single container, we have to pass all these options. So running containers through command line will become very difficult. Why? Because while writing the command, if I have done any mistake, then it will be very difficult to change. Later on, if I want to edit something, then also very difficult to edit in terminal. So as of now, if you see for Mongo, we have written this complete setup and for Mongo Express, we have written this complete setup. So here changing or editing something will be a nightmare. In larger applications, we will have front-end container, we can have back-end container, we can have container for database, we can have Redis, etc. We can run multiple containers and managing everything manually becomes very difficult. So what is Docker Compose? It is nothing but a tool which will help us to manage multiple containers together. Docker Compose will be providing us better and standardized approach. So for Mongo and Mongo Express, we have seen in terminal, we have run that complete command. But using Docker Compose, we will be creating one single file and inside that file, we will be providing all the instructions. Using those instructions, we can easily create and run our containers. So using Docker Compose, what all we can do? We can create containers, we can connect our containers, we can set up our network, we can set up volumes, we can also give environmental variables inside the same file and everything together we can start. And this entire thing will be defined inside one single file. So we are going to create the file like this. File name, let me pass Docker Compose. You can give any file name. The extension of this file will be YAML file. And inside this file, we can define all the Docker configurations. Now here, I am having one terminal. Instead of running the commands in the terminal, what we will do, all the configurations we will be defining inside one single file. And to run those containers, we are going to run this file. And this YAML stands for, let me write here, yet another markup language. So what is this YAML file? This contains Docker configuration. Instead of manually running the commands in terminal, we will write all the configurations inside this file. This file name can be anything, but extension has to be YAML. So previously, what we have done, to run our Mongo container, we have written this complete command. To run our Mongo Express, we have written this complete command. So instead of defining inside terminal, this entire configuration we will be passing inside this one single file. So running containers through YAML file will be giving two major benefits for developers. So first thing, very simple, using YAML file, we will write entire thing in more structural and standardized format. Second thing, whenever we want to make any changes, we can easily make inside the file. But same thing, if we want to do in terminal, definitely it will be time consuming. And while running the command, if we have done any mistake, we will be having the error. Again, same thing typing and again repeating the entire process will become nightmare. So inside YAML file, we can easily modify the changes. Open your project. In root, I will be creating my file. I will write docker compose.yaml. You can see we are having this docker icon as well. We have created this file. Now what docker compose will be doing? It is just going to use this file to define and run multiple containers. In my project, I have to run Mongo container and I will be running Mongo Express container. So both this I will be defining inside this file. So what this Docker Compose will be doing, it is just going to use this file to run this multiple container applications. Remember, Docker Compose is mainly used when we are dealing with multiple containers. If you are having limited containers, then directly in terminal you can run. But if you are having more than one container, then those containers you can maintain using Docker Compose. For this teaching purpose, maybe we are using one or two container, but in real project, you will be dealing with multiple containers. And during that time, Docker Compose will be very helpful. So you should understand how YAML file is written, practice from your end, give instructions for multiple containers and using Docker Compose, create multiple containers. Now one by one, let us understand what we will be having inside this file. I will open my project. So first thing, I will be passing version. Give space. Version I will write 3.8. This is going to represent our Docker Compose version which we want to use in our application. But in latest Docker Compose version, this option is obsolete, which means if you want, you can skip this. But for teaching purpose, I'm just going to keep. Later on, we might get some warning, but we are simply going to ignore that warning. So this is going to represent our Docker Compose file version. Second important thing, you do not have to separate with command all. Second, I will be passing services. Inside these services, we are going to define all the containers. Let me come here. Here we are having services and inside this file, indentation matters a lot. Now I want Mongo and Mongo Express. First service, I will be passing Mongo. Then second service, I will be passing Mongo Express. You do not have to pass these numbers. Inside this service, first I want to define Mongo. Then I will be defining Mongo Express. Doesn't matter how many containers we want inside the project. All that will be defined inside this services section of our file. First, let us work on Mongo service. Bring down, give one tab space. I will be writing Mongo colon. Inside this service, what all data we have to pass? Let us see. Now here we are having service and first service we are going to work on Mongo. Again give colon. Inside this first we will be passing image name. What image we have to use? Our image name is Mongo. We have already seen. Next we will be passing ports. You can write it down. And for port, what we were using, we were passing host port colon, then we were passing container port. But here you do not have to use hyphen p. Directly you can use host port. We will write this hyphen, but 27017 host port colon 27017 container port. Using this, we are performing port binding. Next, we will be passing environmental variables. For MongoDB, what all variables we are having? We are having username and we are having password. For username, I have written Khanam123. For password, I have passed secret. And what are these environmental variables? Directly from here, I am going to copy. For code binding and for environmental variables, you don't have to use these options. Now, how we are defining this Mongo service? Similarly, we can also define Mongo Express service. Accordingly, we will be changing the options. As I mentioned, in YAML file, this indentation matters a lot. So be very careful with these indentations. First, we will be passing image. Our image name is Mongo. Bring this down. Next, I will be passing ports. Bring this down. Directly here, I will write 27017 host port. We are just going to bind with 27017 container port. Next here, I will pass environment. Just come here. If you want, you can just copy from documentation as well. From here, I will copy this. And inside this, I'm just going to paste. Give one space. Here I will be writing. And inside this YAML file, you don't have to write this equal to. You have to pass this colon. Next, come here. I will copy. And inside this, I'm just going to paste. Again here, I will be passing colon. So now we have created Mongo service. Similar way, we can create Mongo Express service. Now just bring this down. Indentation here. I will pass the service name as Mongo Express. Indentation. Next image name. Image name is Mongo Express. Next ports. What ports we have to pass? We are passing 8081 colon 8081. Next I will pass environment. One space tab. Come here. From here I'm just going to copy. Copy all this. And inside this I'm just going to paste. Remove. I will remove this. Just give proper indentation. And in place of equal to, I will pass colon. So inside this YAML file, what we have defined? We have defined the containers which our Node.js application will use and run. So as of now, we have only created the file. We have defined all the configurations. But now what Docker Compose will be doing? Docker Compose is going to use this file and create containers from it. How many services we have defined? Accordingly, containers will be created. In Docker Compose, we are having two commands. First, we will write Docker Compose -f. This is the option for file. Then we will pass our file name .yaml, and then we are going to pass this up command. And how we are going to run? We are going to run in detach mode. Before that, here, while copying, we have passed this caret symbol. Now I'm just going to remove this. Okay, we do not need any symbol. Again, come here. As soon as we run this command, what happens? First, Docker Compose is going to create network. What network it is going to create, that we are going to understand in a second. Next, it will be creating Mongo container, as well as it will create Mongo Express container. And then finally, it is just going to connect everything together automatically. We don't have to do anything. Automatically, it is going to connect everything. So first, it will be creating network, Mongo container, Mongo Express container will be created, and everything will be connected automatically. Okay, this is the first command, up command. Second, we are having down command. Simply, we will pass Docker compose down command. So what this down command will be doing, if we want to permanently stop and remove all the containers which are defined inside this file, then we are going to use this down command. But now let us understand about this network. Previously, I have already mentioned Docker networking is one of the important concept, and if we want to run both the containers, then we will be creating our private network, and containers will be put inside that network so that they can interact with each other. And manually, when we run this Mongo Express container and Mongo container, we have specified network here, and both are on the same network. But in our YAML file, if you notice, nowhere we have specified our network. Why? Because Docker Compose automatically it is going to create the default network and runs all the container inside that network. So Docker Compose will be creating default network and all the containers will be running inside this network. Okay, manually we do not have to specify any network in YAML file. Docker Compose automatically it is going to handle. Now before running this up command, what we will do, our node application was already connected to this Mongo and Mongo Express, which we have created earlier. Now what we will do, first we are going to delete these containers. Okay, directly from terminal you can delete, but from here I'm just going to delete both containers. Delete forever. This also I'm just going to delete. I will also delete the images. Okay, freshly we are going to start. Why we have deleted? Because as I mentioned, here also we are creating the container and we are doing port binding 27017 of the host machine. But previously also we have done same port binding. So if we run, we will be having the error. So first thing, we have deleted both the containers which we created in phase 2. Now I will run my application npm run dev. Now currently we do not have any images and we are not having any containers. So from fresh we are going to start. I will open command prompt. I will write this command docker compose -f. My file name is docker compose dot yaml up command and we will run in detach mode. But here it is not going to work. It will tell this docker compose file it is not able to find inside this path. So whenever we are running this docker compose, we have to define exact file location. So I will come to my project folder. This is my project folder. I will copy this path, come to command prompt. Here I will write cd and paste the path. Now I am inside this to do application. Now here I can run this docker compose command. Docker compose -f docker compose file name dot yaml up command and in detach mode. Hit enter. Now you can see first, as I mentioned, we will have warning for this version. This version is obsolete, so you can simply ignore or remove from the file. But for teaching purpose, I have simply added. If you want, you can remove, no issues. Now you can see both the images are being pulled. Mongo and Mongo Express. It will take time. Let us wait. Successfully, everything has started. You can see image Mongo it is pulled, Mongo Express it has pulled. By default, it has created one default network to do app default and both the containers will be present inside this default network so that they can interact with each other. Then randomly it has given container name as well. If you want, you can change the name. You can define in YAML file, but Docker Compose has given the names as well and both the containers have started. Let me come here. Now you can see in my images, I am having Mongo Express, but inside this container here, I am having the name as to do app. Inside this to do app, I have defined two containers. So both container details will be present and both the containers have started. Now come to project, open terminal. I will write npm run dev. Our server is running on port 3000. First, let me open localhost 8081. Hit enter. Again, you will get sign in option. Username will be admin, password will be passed. Just enter and log in. But here, if you see, previously, whatever database we have created, that is not present here. That is gone. So what I will do, again, I will be creating the database. But carefully, if you notice, by default, we are only having these three databases. Whatever database we have created earlier, that is gone. This is because whenever Docker restarts or when our containers are restarted, we do not have any data persistence by default. If our containers are removed, then also whatever data or database we are having, complete thing will be removed. By default, in Docker, we do not have any data persistence. Data persistence means we have created database to do app, we have created the collection task, and inside that we have added one document, or I think we have added two documents. All these things will not exist once our container is stopped or recreated. So to achieve data persistence in Docker, we are having one more important concept, that is Docker volumes. Next, we are going to see about Docker volumes, but to achieve data persistence, we are having Docker volumes. But for now, we have created two fresh containers. So whatever old data we were having, that is gone. So here I will be writing to do app. Click on this create database. Click on this to do app. I will create the collection. I will add new document. Here I will write title. Title, let me write sleep well. Save. I have added my document. I will open localhost 3000. Hit enter. Now whatever data I have added in Mongo Express, I am able to get that data here. I can also get all the tasks. Hit enter. You can see whichever task I have added, I am able to get. So this means Docker Compose has successfully set up our MongoDB container and Mongo Express container using YAML file. Okay, this is how Docker Compose works. If you want to delete these containers, what we have to write? We have to write Docker Compose. Again, file option. What file? I will write Docker compose.yaml. Simply we have to pass this down command. Hit enter. Now if you see, containers are removed and also default network which we have created, that is also removed. Now if I just write Docker network ls, let me write Docker network ls, hit enter. By default, we will have three networks and previously one private network we have created, only that is present. We can also delete that because we are not using. So here I will write Docker network rm. Then you can pass network name or you can pass network ID. I will write network name, copy and paste. Hit enter. It has been removed. Again, if I run by default, I will only have these three networks. Again, I will come to Docker Compose. You can see containers are gone, but images are still present. Why? Because we have only deleted the containers. We have not removed any images. Again, if I run this command, both the containers will be created and started. And if I want to edit something, easily I can come to this file and make the changes. Let us understand one more important concept in Docker, that is Docker volumes, and why we are using volumes to persist our data. In our Node.js application, what we have done, we have connected to Mongo container, but whatever database we have created, whatever collections we have created, whatever document we have created, that is not permanent. Once our container restart or if we rebuild a container, whatever data we are having inside the database, the complete database itself will be gone. So first thing, remember, containers are temporary in nature, which means if we delete the container, whatever data we are having inside the container, that will also be deleted. Because in containers, by default, all the data will be stored inside virtual file system. So if our container is stopped, whatever data we are having, that data will be gone. And if we restart the container, everything starts fresh from the beginning. Let me come to command prompt. And here, I'm just going to rerun this compose file. Okay, up command, hit enter. Again, containers will be created and by default, I am having one network. I will open browser. I'm just going to refresh this. Now you can see previously whatever database we have created, that is gone. And whatever task I have added, that also I am not able to access. Why? Because entire data is gone, because our data is not persistent. You can't even imagine, if you're not persisting data, how much loss you will be facing. Example, okay, just imagine we have created Mongo container. Let us take an example of e-commerce website. Their users will be login. So basically, we will insert those users inside the database, okay, data of user. Like if you are having some task like add to cart, all that data will be inserted. If you are having any products, then all the products data will be present inside the database. And if user is placing some order, those order information also we will be having inside the database. Everything is working correctly. Till now, we have not done any persistence of data. We have created the container and inside database, we are pushing all this data. Now suddenly or by mistake, you have just deleted this Mongo container. Of course, this would be a big nightmare because this entire data, whatever we are having inside the database, complete thing is gone. Why? Because our database itself will be gone. Why this happened? Because container storage is temporary. Every container has its own file system and its own internal storage. So when our container gets deleted, whatever storage we are having, that will also be deleted. Just imagine real industry problem. We will have Instagram database, banking database, e-commerce database, and if container deletion removes entire thing, just imagine what will happen. Entire user information will be deleted. Whatever user banking information in e-commerce, complete user identity, whatever orders they have purchased, as well as in Instagram, all the posts, each and everything will be deleted. Definitely, that would be disastrous. So what we need permanent storage, and this is where Docker volumes comes into picture. Whenever we want our data to be persistent, that time we are going to use Docker volumes. Very, very important. Again, let me repeat. Whenever we want our data to be persistent permanently, during that time we are going to use concept called Docker volumes. Very, very important. So Docker volume is permanent storage managed by Docker. Okay. This managing is not done by host machine or any container. This is managed by Docker. So what volumes will be doing? They will allow data to survive even after containers are deleted. Okay. Volumes allow data to persist even after containers are deleted. Now let's see how Docker volume works. Okay, simple example. I am having one host machine, and inside this host machine, I have created one container. Okay, in our project, we have created container for Mongo. So let us suppose we have created Mongo container. Inside this, we will be having storage space for storing complete data inside the database. How volumes work is they will be creating one extra space inside this host machine, and this space is managed by Docker. Okay, as I mentioned, volumes will be creating extra space in host machine, but this extra space will be managed by Docker. Then what we will do, this extra space we are just going to mount with our container. So this basically means we are just going to establish connection between container and this storage space. So after that, whatever data I'm storing inside the container, that data is replicated inside this storage space. We are not copying, we are not duplicating. That complete data is replicated inside storage space. For example, here user is getting logged in, user information is stored. So that complete user information will be replicated inside this storage space. Now, if I stop this container and later if I just restart this Mongo container, the data will be still present. Why? Because now directly it is going to fetch from this volume, and this Mongo container will still have access to its all data. If we stop, whatever data we are having here, that is gone, but easily it can fetch from volumes and it will have access to all data. In fact, even if I delete the complete container, the data which is present inside the volume, it is still accessible. Later on, again, if I create container, then easily they can access the data from Docker volumes. So this is important Docker volume concept using which we can implement data persistent while using our Docker containers. Main purpose of volumes. Volumes help us to persist data, save database files, share files, keep our data safe, and it will also survive container deletion. So without volume, if container is deleted, all the data will also be deleted. But with volume, if the container is deleted, then also our data will be persisted, which means our data will be safe and stored. Okay, another example. Just imagine in MongoDB database, you have created one project and you have stored around 10,000 users. Now, by mistake or by anything, you have just deleted the container. Whatever user information you are having, complete thing will be gone. But with volume, your data will be safe and easily you can just get complete user information. How cool is that? Let me show you one more practical example. This is my host machine, and inside this we have created one extra storage using Docker volume. I have created two containers, Mongo container and Mongo Express container. Doesn't matter how many containers I am having, they can easily share the same volume. We will not be having any errors. If I am having only one storage space, both the containers, or even if you're having multiple containers, they can easily share the same volume. Let us see one practical example. Before that, let us understand few points. For volume, we will use -v. Now what we have to do? We have created one storage space inside our host machine. So here we will be passing host path. Then colon, here we are going to pass our container path where we have to do the mounting. Practically, let us see Ubuntu container. Here in my host machine, I will be creating one container Ubuntu. And inside this, what I will do, I will be storing some data. For that, I will create one data folder. And this data folder, I'm just going to replicate in storage space. Then whatever files and whatever data I will be adding inside this folder, same thing will be replicated inside this Docker volume. To create an mount volume, we will be using this -v option. Then we are going to provide complete absolute path of our host machine. Then we are going to pass this colon followed by container path where volume should be mounted. Okay, remember we have to provide complete absolute path. For example, if you are using Windows, then we will have C colon users, etc. etc. Now practically, let us see this. First, I'm just going to delete my Docker compose. Down command, everything is removed. Clear the screen. Now here, I will write doc run enable interactive mode. Come down. I will change the name as well. I will pass Ubuntu demo. Let me pass Ubuntu demo 1. Then mounting. Inside this, we have to pass absolute path of our host machine. In my downloads folder, I will be creating new folder. I will give the name as data. Open this, copy this complete path, and here I'm just going to paste. Followed by colon. Next, I will give the folder name which has to be created in my container. Now I will be using this slash. Folder name, I will be passing data. Again caret. Then lastly, I will be passing my image name, that is Ubuntu. Hit enter. It is unable to find the image. So first locally it is going to pull the image. Now I will do ls. You can see data folder is created. Now we have done mounting with this path. We are just going to mount with this data folder. Now what I will do, inside this data folder, I will create one file and I will be adding some data inside that. First, let me clear the screen. I will write echo. Let me write some comment. Hello, Docker volume. I will pass data folder. Inside that, I will be creating one file. Give the file name as testfile.txt. Hit enter. Now I'm just going to do ls. I will come inside data folder. Again, I will do ls. You can see we have created the file, and inside this data folder, I am having this testfile.txt. Now, if I want to see the output, I will write cat testfile.txt. Hit enter. So whatever echo I have done, this complete data we are having inside this testfile.txt. And where this file I have created inside container. But let me open this data folder. You can see inside this data folder also, this data is replicated. Here I have not created the file, but still this file is replicated. If I open this file, you can see inside this file, whatever content I have passed, that content will be present. Okay, manually we have not created test file in a desktop. We have done mounting. So successfully we are able to mount, and whatever changes we are doing inside the container, that complete data is replicated in that mount path. Okay, this confirms our Docker setup is successful. Now what I will do, I will stop the container. I will write docker ps. Okay, first let me exit from here. I will write docker ps. I have exit from the container. So currently no container is running. Now what I will do, I'm just going to restart my container. I will write docker start, come to Docker desktop. I will copy this container ID and inside this I will paste. Hit enter. My container has started. First I have exit. My container was stopped. Now again I have started my container. But I have to open this container in interactive mode. I will write docker execute command in interactive mode. Then I will be passing my container name. So here I have passed the contain. Okay, I have passed the wrong name. No issues. I will copy and inside this I will be pasting. If you are in Windows, we will pass bin sh. Okay, shell path. If you are in Linux, you can pass bin bash. Now I will do ls. You can see still my data folder is present. I will come inside data folder ls. You can see successfully my files are present. My folder is present. It is not been deleted. Even after stopping the container and restarting it, still my folders and files are present. If I would have not mounted, then my data folders would have gone. But without volumes, I would not be having this data folder and data present inside this file. Again, exit. Now what I will do, I'm just going to delete this container. Come here. I will stop. I will delete this container. Now I will be creating brand new container. Come down. Now here, name, let me pass Ubuntu demo 2. Then with what path I have to mount? I have to mount with this path. Okay, let me just copy this. And here inside this, I'm just going to paste colon folder. I have to create data. Image name, I will be passing Ubuntu. Hit enter. Now new container is created. I will do ls. Data folder is present. I will come inside data folder. Again, I will be doing ls. You can see in this brand new container, I have not created this test file. But as we have mounted earlier, this data is replicated from this folder which we have created in our desktop. I hope this concept is clear. Using Docker volumes, we can easily persist the data permanently. If you want to see the output, here I can write cat testfile.txt. Hit enter. So whatever content I have added, that content will also be present. So what Docker is doing? Docker is going to manage volumes automatically. And Docker will be storing volume separately from our containers. Okay, doesn't matter if our container is stopped or deleted. If we have mounted to this Docker volume path in our desktop, then easily we can have access to that complete data. So always remember, deleting container is not equal to deleting volumes. Now I will just exit from here, clear the screen. We are having few important commands in volumes which you have to understand. To see all the volumes, you have to run this docker volume ls. Hit enter. Now you can see by default we are having some volumes. If you want, you can also see in Docker desktop we are having this volumes tab. We can see list of all the volumes in Docker desktop as well. Next, we can also create the volume. For that, we will write Docker volume. This is called as named volume. Later on, we will study it more deeply. Docker volume create. Let me give the name as my volume. Hit enter. My volume is created. Now I will do Docker volume ls. You can see this volume is present. If we want, we can inspect this volume as well. For that, we are having Docker volume inspect command, and then we will be passing our volume name. That is my volume. Inside this, we will have lot of information when this was created, what is the driver, labels, I am having its mount point, what is the name I have given, and few more options. This is how we can inspect the volumes. But definitely, you should be having question from where we got this mount point. Previously, when we mounted our host path and we have passed their container path, so inside this, we are specifying complete absolute path where our volume should be mounted. But now, when we created named volume, we have not specified any path. So in this case, whenever we are creating volume, what Docker will be doing, Docker is going to store these volumes in its own internal storage depending on our operating system. So in our operating system, in our host machine, in this path, I will be having my mount location. So while creating the volume, whenever we are passing the name, it is called as named volume. We can remove the volume as well. We can write Docker volume rm. Then we will pass volume name. Volume name, I have passed my volume. Now if I see Docker volume ls, you can see whatever volume I have created, that volume will not be present. We have seen hyphen v flag, okay, which stands for volume flag, and using this we have attached our volume with our container. But this is not only one type. In total, we are having three ways of attaching volume to our container. Now directly, if I create volume, Docker volume create, I will give my volume name as my volume. Now currently the volume which I have created, it is not attached to any container. But directly if I create and leave the volume, it is not going to make any sense, because the actual meaning of volume is to attach it to running containers. Because what is the main purpose of volume? The main purpose is to persist the data. So basically we are having three ways of attaching volume to our container. Let me write here. First, we are having named volumes, okay, which we have already seen. Second, we are having anonymous volume. By the name itself, you can understand this volume will not be having any name. And last, we are having bind mount, okay. This is the example which we have seen. When we saw Ubuntu example, we have just given our host machine part and then we have just mounted with our container. So this example we have already seen. But deeply, let us understand all of this. Okay, we are having one more flag, that is mount flag. So for volumes, you can either use hyphen v flag or you can use this mount flag. So both the flags we are going to understand. First, let us talk about named volumes. And who is going to manage Docker volume storage? Our Docker is going to manage. So using this named volume, we are going to give name to our volume. Okay, this will be custom name. You can give anything. So what will be the syntax? We will write hyphen v. Then we are going to pass our volume name. If you want, you can use create command and create the volume. If you are not having the volume, then you can just simply pass the volume name, whatever you want. If it is existing, accordingly it is going to mount. If it is not existing, first it will create the volume and then we are going to mount with our container path. Okay, whatever we are assigning, with that path we are going to mount. So now let us see the example. Docker run, entire thing remains same. Volume name, let me pass Ubuntu demo. I have not created the volume. So first volume will be created and after that it is just going to mount. So here I will be passing data, and this location based on the operating system, we will be having the path defined. So here for this named volumes, Docker is going to manage the storage. Who will manage the storage? Docker is going to manage the storage. And this type of volume is best for databases. For production apps also, you can use this named volumes because you can refer volume by name, and of course for persistent data. So named volumes are one of the most popular ways of creating and managing our Docker volumes. Why? Because we are having the volume name and easily we can refer the name instead of passing the entire path. Okay, this will be the syntax of named volume. Next, we are having anonymous volume. For this, syntax will be, let me write here, Docker run. Again, we will be using hyphen v. Directly, we are going to pass mount path. Okay, basically, we are going to pass our container path. We will not be specifying any volume name. We will not be giving any volume path. Directly, we are going to specify mount path. Since there is no name for the volume, so that is the reason it is called as anonymous volume. And later if we want to refer this, then it is not possible. So then why this volume exists? This volume exists basically for temporary storage. So if we are not passing any name, then Docker automatically it is going to create anonymous volume. And after creating, by using this command, you can easily check anonymous volume as well. Docker volume ls, it will list all the volumes, and inside volume name column, instead of having volume name, we will be having some numbers, or basically we are going to have some ID. So definitely, as I mentioned, later on we cannot refer this anonymous volume. So we will have lot of problems with it because names are random. Names will be given random. We will have some random numbers along with the IDs. So in that case, it becomes difficult to manage, difficult to identify. We will not be able to identify what volume we have to mount with our container, and difficult to reuse, difficult to manage, difficult to identify, and difficult to reuse. So definitely this is not good for production apps. You cannot use at all. For databases also we cannot use, because without name we cannot identify the volume. As well as if you want to do long term storage, in that case also these anonymous volumes are not used, because later we might not know which volume belongs to which container. That is the reason mostly we avoid this anonymous volume. Last, we are having bind mounts. Here we will have direct connection between our local folder and container folder. This example we have already seen. So how we will be passing this? Docker run -v, then we are going to pass our host directory, colon, then we are going to pass our container directory. So here the main difference is, here we are passing our host directory. So the host operating system, it is going to manage the storage, because explicitly we are going to define complete host path. Okay, whatever local folder we are having, directly we are going to connect to our containers. But in named and anonymous volumes, our Docker itself is going to create and manage the storage. For bind mount, our host operating system is going to manage the storage, but named and anonymous, Docker will be creating and managing the storage. Bind mount is also very useful in development. Whenever you change any code, then instantly it is going to reflect inside the container. So this is very useful whenever you are using Node.js, or if you are using React or front-end development. In that case, this bind mount is very helpful. Similar to this, we are having another flag, mount flag. This will also do the same work. In this also, we are having named volumes, anonymous volumes, and bind mount. -v flag, which I have shown you, this is basically old style, but this mount flag will be more readable, it will be more explicit, and it is mostly preferred in production. So this is modern way of writing, but this is old style. Let us see some examples. First, let me write the syntax. We will write mount, and then we are going to pass the type. Type here, it can be volume or bind. Then I will be passing source. Inside this source, we can pass volume name or folder path. Then next, we are going to have the target. Inside this, we will pass folder inside the container path. We will write -mount. Inside this type, you can pass volume. Inside the source, you will be passing the volume name, or you can pass the folder path. And inside the target, you're going to pass the container path. So definitely, this is more readable. So that is the reason it is preferred in production. I will write the example for named volume. Docker run -mount. Then we will pass type. What will be the type? Type will be volume. Then next we are going to pass the source. Let me pass named volume. I will write here Ubuntu demo, and target. I will be passing container path. So here I will be passing data folder. So in this way, named volumes will be given. So here what it will do, if we are not having this volume, first it is going to create this volume, then it is going to connect to this folder, and whatever files and code we are adding inside this folder, it will be replicating inside this volume. Next, anonymous volume, everything remains same, but we will not be having source. Rest entire thing remains same. Here, no source name will be given. So Docker automatically creates random value name. We will be having some numbers, okay? We will have some alphanumeric number. Then bind mount, everything remains same. Here, type, we will be passing bind. And inside this source, we will pass complete desktop path, okay, folder path. And inside the target, we are going to pass the container path. Entire thing remains same. So here what Docker will be doing, Docker directly connects our laptop folder inside container. Whatever path we have given, with that one it is going to connect. Next, we are having one more important command, that is prune command. Basically, this command is used to clear unused anonymous volumes. Suppose I have created 3 containers and I am just mounting this to anonymous volumes. Now after some time, I have deleted all these 3 containers, but anonymous volumes are still present. So they will be taking extra space. Definitely, I do not want that. but I'm having one more container, and inside this I have attached one more anonymous volume. This container is not deleted, so here I'm having volume which is attached to running container, but these three volumes, the containers which were attached, those are deleted. So what this docker prune command will be doing, docker volume prune, it is going to remove all these unused volumes. This volume is attached to running container, so this will not be removed, but unused volumes will be removed from our operating system. But if you want to remove one specific volume manually, then we are having docker volume, again rm, then whatever volume name we are having, that we are going to pass. This prune command, it is going to remove unused volumes and it is going to free up the storage. It will not remove active volumes which are attached to containers. And why this is helpful? This is helpful for Docker cleanup. Now here your homework will be yourself create three containers attached to volume. Okay, you can either use this volume flag or you can use this mount flag. Whatever we have learned using those concepts, you have to create the containers and you have to bind to volumes. And after that, you have to delete the containers and then you have to run prune command and see what are the changes and how it is affecting our code. Okay, just try from your end successfully. If you are able to do, let me know in the comment section. Now you have understood Docker Compose. You have understood why Docker volumes are used. What is the purpose of Docker volumes? Now we will combine both Docker Compose and Docker volume in our project. Previously, in our Node.js application, when we restarted Mongo container, complete database was gone. Now inside this YAML file, we will implement volumes so that whatever data we are adding, that should be persisted. I hope you have understood what is Docker volume, how volumes are created, how we are mounting this volume. We have seen a lot of example. Now finally, let us work in a project. But inside the images, we are having all these three things. I'm just going to delete. Open project. Now for this Mongo service, below this environment, I'm just going to define volumes. So here I will be writing volumes. First, give one space, hyphen. What we have to pass? We have to pass our host folder path. I will open. I have already created the folder. From here, I will delete the file. Open this, copy this complete path, and inside this, I'm just going to paste. You do not have to wrap in double quotes or single quotes. Next, we are using Mongo. For Mongo, we are adding volumes. I will open Mongo official image, scroll down. Here, while creating the volume for MongoDB, we are having this default path inside the container. In this location itself, entire data will be stored inside the database. So exact same thing I will copy and here I'm just going to paste. Okay, you just focus on the slashes, how we have passed exact same way you have to pass. With this one line, we are passing volumes in our project. Now you are aware why we are passing this one line. Open this to do app. From here, I'm just going to copy this path. So here, I will write cd, paste the path, hit enter. Now I am inside my folder. To use Docker Compose or to execute YAML file, we have to be in the same folder where file is present. Now I'm just going to run that compose. Docker compose -f docker compose.yaml file and then command. Hit enter. Now you can see Mongo and Mongo Express. It has start pulling. Okay, it will take time. Let us wait. So we have attached the volume. So what Docker Compose will be doing? Automatically, it will be creating the volume. It is going to attach the volume with the path we have provided and it is just going to persist our database. So next time when we are deleting the container, then also our database will be present because our containers are temporary but volumes are permanent. Now here Mongo Express image is pulled, Mongo image is pulled, default network is created and two containers are created. I will come to my application. I'm just going to run my server npm run dev. As server is running on port 3000. Now continuously we will be having logs. I will do Control C, hit enter. Now come to Docker image. Successfully we have pulled the image and here we are having container. As soon as I exit, these containers have stopped. I'm just going to restart this containers. Our application is already running. Now I'm just going to refresh once. I will be creating database, open, create a collection, add one document, eat fruits, save this, document is added. Now come here, refresh once. Successfully, I am able to get that document. Now what I will do, I will stop the container. Let me just open this. I will stop both the containers. Come back. Now I'm just going to delete the container forever. Now if I refresh, containers are deleted. So I will not be able to access Mongo Express. Clear this. Now again, I'm just going to run this Docker Compose. Hit enter. Again, you can see containers are created. Again, it is running all the logs. I'm just going to do Control C. My containers have stopped. Now I will come here. I'm just going to start both my containers. Now refresh once. Now, as soon as I refresh, you can see database exists. I will open. I am having this task, and inside that I am having this record. Previously, as soon as I deleted my container, I was having this error. But here, as soon as I refresh successfully, I will have access to complete data. And this is possible only because of volumes. If we would have not added this line, then whatever database and data we were having, that would have been deleted. So what you should understand, containers lose data after its deletion. So what volumes will be doing? They are just going to persist the data. So MongoDB database should always use volumes. Very important. If you are not using volumes, then maybe if you're deleting the containers, entire data stored inside the database will be removed. Who is going to manage the volumes? Docker will be managing the volumes, and named volumes are best for databases because easily using names we can refer the volumes, and bind bounds are best for development. As I mentioned, it is more readable and it is preferred in productions. Volume mounting, what it will do, it is going to connect our storage inside the host machine with our container so that our data remains persistent. We have completed phase 3 of this course. And now it's your time to understand complete phase 1, phase 2 and phase 3. Once you understand this, only then proceed to phase 4. Let us start with phase 4, and you are going to enjoy this a lot because finally we are going to Dockerize our entire application. We will publish our image in Docker Hub as well. So one by one, we are going to understand all the concept. So till now, we have created a Node.js application. We have created Mongo container. We have created Mongo Express container. We have studied port binding, Docker Compose. We have learned volumes. We have done lot of things, but still our Node.js application is running in our laptop. How I am running my application? npm run dev, and my application gets started. So the main problem is if another developer wants my same application manually, they have to install entire thing. They have to install all the dependencies. Version should be matching each and everything manual. They have to set up. So what this will be doing? This will be creating works on my machine problem. So this is the reason why Docker was created. So what we will do? We are going to Dockerize our application. So Dockerization means whatever application we are having, we are just going to convert to Docker image. So it can run anywhere consistently. And if any developer wants my application, I can easily share my image. Doesn't matter which application you are using. If you are using Node application, Python application, okay, let it be any application. You can convert all those applications into Docker image. Now currently what I am having my Node.js application, and the name of my application is To Do app. Okay, this is my Node.js application To Do app. So what we are going to do, this application I'm just going to convert to Docker image, and later on from this image we can create the containers so that each and every developer who is getting this image, they will be getting the same application. So the process of converting an application into running container is called as Dockerizing our application. Again, let me repeat, the process of converting our application into a running container is called as dockerizing our application. And once the Docker image is created, we can easily share this to a team member. Right now, in this Docker course, what we will do, manually, we are going to convert our application to Docker image. But when you're working in larger companies, manually, they will not be doing all these things. Instead, they will use the tools like Jenkins in CI/CD pipelines. I believe you have heard about this CI/CD pipelines. Using this, all this work will be done automatically. Manually, we don't have to do entire thing. But as a beginner, you should be aware how we will Dockerize our application. So this will be the first step. Later on, you can proceed with Jenkins. You can learn how this process will be done automatically. So using Jenkins, we can convert our complete application into Docker image, and then this image can be pushed either in a private repository or public repository. So that doesn't matter, let it be private organization or public organization, they can easily access this image. That will be done automatically using Jenkins. But to Dockerize our application, very important thing, we are going to use one file that is called as Docker file. So what is Docker file? It is step-by-step instructions given to create our Docker image. So basically, our Docker file will be acting as a blueprint. Using this blueprint, we will be creating our Docker image and containers. Or you can tell, we will be writing all the instructions how our image has to be created. So that instructions one by one and carefully, very slowly, I will be teaching you, so that doesn't matter what application you are dockerizing, you should be having each and every syntax in your mind. Let's take one analogy to understand more about Docker file. You want to prepare pizza, but you don't know how to prepare pizza. So definitely what we will do, we are just going to refer recipe, or you will be watching some YouTube videos. So inside this recipe, what all things will be mentioned, what ingredients has to be used, what are the steps we need to follow, and complete instructions will be given. Using this same recipe, not only you, your father, your brother, your sister, anybody can prepare pizza. Similarly, inside this Docker file, we will have app setup steps. How our app should be set up, what are the dependencies we are going to use, what are the commands using which we can run our application, environmental setup, each and everything related to our application will be present. So now, using this same Docker file, any developer can create the same application. I hope till here it is clear. In Google, just search for Dockerizing an application. Scroll down, you will be seeing the documentation. Click on this. Just scroll down, you will see complete syntax of a Docker file. We are having some commands one by one. We will understand each and every line. One more important point which you should understand. Let me copy this, and inside this I'm just going to paste. Whatever instructions we are passing in Docker file, it is going to run sequentially. First, it will be starting from here, then it will move here, then it will move here. Okay, sequentially, it is just going to run. So in Docker file, we are going to write all these instructions, and in sequential manner, each instruction is going to run. Okay, we will have lot of instruction, but these are the common one. We will have some more instructions, like we can also pass environmental variables as well. So basically, using this Docker file, we are going to build this flow. First, we are going to create Docker file. In that Docker file, we will be passing all these instruction one by one. We will understand. Then from this Docker file, we are just going to do Docker build. So once we have done build, our Docker image will be created. And from this image, what we will do, we will write Docker run. As soon as we do Docker run, what will happen? Our container will be created. So this is the complete flow which we are going to see in this complete phase. Now let us start with this from. One by one, deeply, I am going to explain you. First instruction from. Just consider Mongo image or Mongo Express image or Node.js image. Every image which has been already created will be having one base image. Whenever we write from, we are defining our base image. So what base image mean? For example, I want to run one node application. To run node application, what is the basic requirement? I should be having node already installed on my system. If node is not installed on my system, then I cannot run any node application on my host machine. Similarly, when my application becomes Docker image or Docker container, inside this I want some dependencies should be already present. Now, currently what we are using Node.js application. When my application is converted to Docker image, later to Docker container, inside this container, Node.js should be already present. So inside this from, we are going to pass the base image, that is nothing but Node. If you are using different applications like Python, accordingly you have to pass the base image. But for Node application, my base image will be Node, and we are going to pass the colon, and whatever version we want, we will be passing that version number. So this is my to-do application, and to build this to-do application, first we should be having the base image. And what is that base image? Base image is Node. Now I will open Docker Hub. I will search for Node. Click on this, and here you can see we are having different versions of Node. Now what I will do, I am using 24. So let me just click on this 24th version. Click on this, and inside this also you can see we will be having base image. Why for this also we are having base image? As I mentioned, whenever we are creating Docker image, they will be having some base image. So node is also an image. So for node also we will have one base image. So what base image we are having here? Let me show you. For node, you can see here we are having build pack devs form. Okay, this is the base image for Node.js. I will copy, and inside this I'm just going to paste. For Node, behind the scene, it is going to perform all these things. We do not have to write anything. Only for this application, what base image we need, that we are going to pass. And again, below this, we will be having Debian. Okay, you do not have to understand all these things. In this way, in Docker, image layers will be created. Layers are another important topic which we are going to see later. So inside from what we will be passing from base image, I will write node. I will be using the version 24. When my Docker file is executed, from here it is going to start, as I mentioned, sequentially it is going to execute. So first it is going to download official image of node, and everything related to node will be set up inside our container. Okay, if it is not available locally, then it is going to pull from Docker Hub and it will be available in our container. I hope this from is clear. Next, we are having working directory. Our container is created. Okay, inside this container, we are going to create one folder. So this folder will be our working directory. So using this command or using this instruction, we are going to set or create the folder inside container. So once this folder is created, inside this folder, we will be copying all the project files, and whatever commands we have to run, we are going to run inside this working directory. Suppose I want to run npm install, I will be inside this working directory, and then easily I can run this command. Very important to pass this working directory, because once we pass this working directory, after that whatever instructions we are having, okay, all these instructions will be working inside that directory itself. Next, we are having copy instruction. Now currently where we are having our complete project, we are having complete project in our host machine, and inside the host machine we are having one project folder. Now what this copy command will be doing, all this project folder, it is going to copy inside this working directory. Okay, files and folders, whatever we are using inside this project, that complete thing from our host machine, all the files and folders will be copied into image. So example here, I just want to move package.json from host machine to image. I will be writing package.json. So we are having our application to do app. Inside this, we are having files and folders. All files and folders we can copy and make them available inside our container. Okay, from our laptop, we are just copying to our container. Then next we are having run command. In our Docker file, we can have multiple run commands. So first, when we are copying, we are just going to copy package.json file. Why? Because whatever dependencies we are having inside package.json, that is going to remain unchanged. For example, I am installing Express, I am installing Mongoose, I am installing NodeMon. All the dependencies will be present inside package.json. So whatever dependencies we are having, that will be unchanged. If we are having package.json, whatever dependencies we are having, how we are going to bring inside our system, we will simply write npm install. So inside this run command, we are going to write npm install. We will pass package.json and then we will be passing npm install so that all the dependencies will be installed in a container. So first, why we are passing only package.json? Because dependencies remains unchanged. Once npm install is done, what Docker is going to do? Docker is going to cache that information. Later on, again, if we want to install and if Docker is saying packages or dependencies are unchanged, directly from cache it is going to take. Again, it is not going to reinstall. So that is the reason first we will copy package.json and inside the run command we will pass npm install. So what this run command will be doing? It is just going to execute the instructions inside our Docker image or container. Okay, doesn't matter what command you want to execute, we will be doing it using this run command. Next, what we have to do? Here, I am having my project. We are having package.json that is copied and all dependencies are installed. Apart from this, we are having some files folders. Now, from my laptop, I have to move into my image. So again, what we will do? We will be using copy command. Then whatever files or whatever folders we want to copy, we can easily pass the path. So simply in copy command, what we will write? We will simply pass these two dots. First dot, it will represent our laptop, that is source. And second dot, it is going to represent a destination inside the container. Using working directory, what folder we have created? We have created the folder slash app. So this will be the destination folder inside the container. Whatever files and folders I am having inside the source, that will be copied in my destination. We are having expose instruction. What this will do? This is just going to expose port to our image. So I can write expose 3000. How our server is listening on port 3000. Similar way, using this expose, we are exposing port to our image. Now our application listens to port 3000. Okay, expose does not mean we are doing port binding. Simply, we are telling our app should listen to port 3000. Last, we are having CMD instruction. Similar to this run command, we are having this CMD instruction. In a Docker file, we can have multiple run commands, but we can only have one CMD instruction. So you can assume like once a Docker image is created and once our container is set up, what command is used to start our application? That final command we will be passing inside CMD. Okay, for example, successfully my container is created. Now what I just want to run my Node.js application. So for that, what we are using here, we will simply write npm run dev, but we can also use node, whatever file you are having, that file name you can pass. So inside cmd, we will be passing this final command, but we are going to pass as an array of string node, this will be string, and then whatever file I have to execute, that will also be a string. Let us revise. Inside this from, we will be passing the base image, working directory, on which directory we are going to work. Then we are going to copy package.json. Then using this run command, we are just going to install all the dependencies. Then again using this copy command, we will copy remaining files and folders. Then using this expose, our application will be listening to this port, and using this command, finally we are starting our application. As soon as our container runs, our application is going to start automatically because we are already passing that instruction. Now let us start creating Docker file. Come to project. In my root, I will be creating Docker file. Exact same name, no changes inside the name. Docker file. You do not have to give any extension. Exact same name you have to pass. First instruction, we are having from base image, I will be passing node. If you want, you can pass the version, but I will simply write node. For node also, we will have base image, and for that base image, we will have another base image. So internally, multiple layers will be downloaded because each and every image will be dependent on another image. One more thing I forgot to mention, we are also having env command. Very important. Env stands for environmental variables. Inside this, definitely we will be passing sensitive information. So currently, what sensitive information we are having? We are having MongoDB username as well as MongoDB password. So both that information we will be passing it here. So directly below from I will be writing env. I will write MongoDB username is equal to, let me write Khanam 123. If you want to come to next line, just give one slash. If you do not want to give slash, again, you have to write the exact same line. I will pass env password. For this environmental variables, you can give any logical name. Password, I will write secret. Okay, let me write here slash and I will be removing this env. Next instruction, I will be passing working directory. So when my container is created, I will be creating one folder to do app. So in place of working directory, you can also use run command and then you can pass mkdir, whatever folder you want, you can create. But for this, we are already having instruction. So this working directory, automatically, it is going to create this to do app folder. Next, what I will do, I will use this copy command. Currently, I'm in my project folder. So whatever files and folders I'm having, I'm just going to copy and move to this folder. So this will be my current directory. Then another dot destination folder. So in this folder, all the files and folders will be copied. Next, I will be writing run command. First, I'm not copying package.json. Okay, later on we will see that. But now I will write npm install. So while copying, we will have package.json, we will have node modules, we will have each and everything we are just copying. Later on, we will see how to ignore that. But as of now, after copying, we will run npm install so that all the dependencies will be installed in a container. Next, finally, we have to start our application. For that, we will write this cmd. I will pass node and I have created app.js. If you have created server.js, index.js, accordingly, you have to pass that name. But there is one problem in this cmd command. Once my container is created, okay, I am inside my container and here we are doing node app.js. But inside this container, no app.js exists. It exists inside this folder to do app. So I have to come inside the folder and then I have to run this app.js. So what we will do, here we will also pass our folder name. I will write to do app. Inside that I am having app.js. I hope you understood this complete Docker file. Question is, we have created environmental variables, but where are we using these variables? I will come to app.js. While connecting to database, we are passing this username and password. We are simply hard coding these values. So what we will do, above this, I will create the variable username is equal to how we have to access process.env. I will copy this variable and then I'm just going to paste. Same thing, I will copy. Next, I will be passing password. Come here, copy this and here I will be pasting. Remove this. In place of double quotes, I will be using this fix. I will just pass username and then in place of this, I will be passing password. But without giving username and password, directly if you lock this one, in that case, you will be having the result undefined. Why? Because currently, this environmental variables we are not having in our application. It is present in our Docker file. So once our image is built, only then it will have access to these values. Now, even if I see the application, you can see it has been crashed. Why? Because it is not having access to these values. It will be giving undefined. But important, we should pass this one and we should make these changes. Building Docker image means converting our application plus dependencies plus setup into a reusable Docker package. So now we are having complete Node.js code. Okay, we have copied entire thing. Inside that, we have package.json. We have done npm install and we have installed all the packages. So we are having all the dependencies. We are also having our Docker file ready. Now, what we are doing, we are going to combine entire thing. Basically, Docker will combine entire thing and we will be creating Docker image. Till now, we have not created any image. We have done only setup and we have given instruction how our Docker image has to be created. If we are not building image, then in your team, if 100 people are having, then manually they have to do all the setup. But if we are having this Docker image, each and every developer, they can pull the image and they can get the exact same application without installing any dependencies. Because inside this, we have already given instruction to install all the dependencies and we have done complete setup. So what will be the command? Command will be Docker build command hyphen T. This stands for tag and my image name I will be passing to do app. And then I will be passing dot. Dot means current folder. So in this current folder, Docker is going to see for Docker file. If you want, you can also give the versions. Here we will be passing colon. So first time we are building, you can give 1.0. Okay, anything like that. If you do not want, you can skip the tag as well. But this is the command Docker build hyphen T tag. We are giving our image name and then we are just giving our current directory. In whichever path your folder or your current project is present, you should be inside that path. If you are not inside that path, you can do simply and whatever path you are having, you can give that path. I will write the command Docker build hyphen T. My image name I will pass to do app all in lower cases. Then I will be passing dot, which means inside this current path, I have to find my Docker file image and it has to execute. Hit enter. Now you can see building has started. So this is how Docker image build process it is going to start. It will take some time. Let us see how this will be working. As soon as we run this command, first what happens, it is going to read Docker file. Okay, step by step instructions it is going to read. Then base image will be created. In from we have already passed base image. Then below that, we are having all the instructions. So for each different image layers will be created and in sequential manner, they will be executed. It will copy all the files and folders. It will install all the dependencies. And finally, our image is created and our image name we have passed to do app. While passing the image name, everything will be in lowercase. So inside this from env working directory copy, each and every instruction will be treated as different layers. Why? Because in Docker, layers will be cached. So that is the reason every instruction will be created as different layer. Now building is successfully finished and our image is created. You will be having one warning. Do not use MongoDB password. You can simply ignore. Let me come to Docker image. And inside these images, you can see our image is created. You can also verify that here. Let me clear the screen. I will write Docker images. Hit enter. Successfully, we have created our image. Till here, if you have got all the output mentioned in comment section, I have created image. Okay, now image is created. Next, what we have to do? Definitely, we have to create the container. I will run the container and also access its terminal. So for that, I will use Docker run interactive mode. I will change my container name. I will write final app. Okay, this is my container name. My image name is to do app /bin/sh. If you are using Linux, then you have to pass /bin/bash. Hit enter. My container is created. I am inside container. I will do ls. You can see directly inside that I am having all my files and folders. You can do ls or you can do dir. You can find all files and folders present inside my container. So in my working directory, successfully, I have copied all the files and folders. To see working directory, let me write pwd, and you can see in my container this folder is created which we have passed here. Then all the files and folders are copied, all the dependencies are installed, and my application has started. Let me come here. Come to containers, you can see my container is created. So whatever application we have created, we have dockerized our complete application. We have created the image, and from that image successfully we are able to create container. So using build command, what we have done, we have created image, and using this run command we are just creating and starting our container. Now currently in total we are having three images: Mongo Express, Mongo, and our application for which we have created the image. And all these three images will be representing one single application. But in real life this is not going to happen. Using Docker Compose you can run all the three images together. So inside this YAML file, let me open. Now we have created the image, we have created the container. So inside this YAML file, under services, we have given Mongo, we have given Mongo Express. You can define your to-do app. You can give all image name, container name, port binding, everything you can pass, and you can create complete instructions here. From your end, write all the instructions for our application image which we have created, and let me know what instructions you have written in comment section. But here we are having one problem. You can see while copying all the files and folders, we have also copied node modules folder. But definitely we do not need to copy these node modules. When we run this npm install, let me open Docker file. When we run this npm install, automatically we are going to have node modules. So here in this case, while copying, I do not want to include my node modules folder. So what we will do, we will be using docker ignore file. So how we will create, in my root, I will write dot docker ignore. In this file, we are going to pass which folder or which file we should not be including inside the image. Okay, not only this, while pushing, suppose in your project you are having env file, this also we will not be including. We can have some logs, we can have some secrets, this node modules, all this file we should not copy inside our image. Why? Because when our image is created, image size will be very large, and while building it will be very slow because it has to pull lot of files and folders which are present inside node modules, and it will be including unnecessary files which we do not need in our application. As well as we will have security risk. Why? Because in env file mostly we will have apis, we will have secret passwords, usernames, all this sensitive data we will not be pushing inside the image. If you know about Git, in Git also we will have Git ignore, where we will be passing all the files and folders which we should not be including. Similarly, inside Docker also, we are going to create Docker ignore file. Inside this, I'm just going to pass the file path. Inside this, we will be passing file path and folders which we should not include. Now currently, I do not want this node modules. So here, I will be passing node modules. That's it. If I was having any env file, any logs file, all that I would have included here. If I do not want index.html, in this way I can pass. Now I will remove this. In Docker file, we are already doing npm install. So again, while copying, I do not want to include this folder. So now what this copy command will be doing, from this project folder, it is going to copy all the file, but it will include only this folder because it is mentioned in docker ignore file. Now I will come here, exit from this. What I will do, I'm just going to delete my image. For that, I will write docker rmi, my image name is to do app. I am not able to delete the image because I have created container from that image. So first, let me come to container. From here, I will copy this container ID. I'm just going to delete the container. Hit enter. Container is deleted. Now I will be deleting my image. Now come here. You can see that container has gone, and also I have deleted my image. I will clear my screen. Now what I will do, again I'm just going to build my application. For that, we will use this build command, docker build -t. My image name will be to do app, and this will be current folder. Hit enter. It will take some time. Okay, you can see one by one, as I mentioned, every instruction will be treated as image layer. So one by one, all the instruction is going to run. Let me clear the screen. I will run Docker images. Successfully, my image is created. You can see my image is created. Now from this image, I'm just going to create the container. Exact same thing. I will hit enter. I'm inside the container. ls. Now you can see we have not included node modules folder, but npm install is executed. So successfully, again we are having access to node modules folder. Okay, if we are running this by default, we are going to have this node modules folder. So that is the reason we are not including while creating our image. Next, we will understand Docker layers and caching. Important again. First, let us understand the problem. Suppose every time we are building image. For building, what command we have used? Docker build -t, our application, okay, our image name and current directory path. So what Docker will be doing? Docker is going to reinstall all the packages. We have passed npm install, so it will be reinstalling all the packages, rebuilds everything. Okay, whatever we are having, it is going to rebuild everything. And how it is going to start? Completely from scratch. So it will start from zero. So using all these things, our setup becomes very slow. And definitely, if it is slow, we are wasting lot of time. So the solution for this is Docker uses layers plus caching concept. Multiple times I have mentioned, whenever we talk about Docker image, this image is having different layers. What exactly these different layers are, whenever you are building your own Docker image practically, then you will understand this concept better. But for now, whenever we imagine Docker image, you can think as it consists of different layers. This makes our build faster, optimized and efficient. So first, in every image, what we will be having, in every image, first we are going to have base image, necessity to run our application. On top of that, we can have some layer. Okay, let us take layer 1. Again, on top of that, we can have another layer. Again, on top of that, we can have another layer. And finally, on top of this, we will have our application. Our application is to do app. So in every image, we are going to have this base image, and this base image is generally very small Linux based image. Linux based image. If we consider node, we have seen we were having some bookworm. Below this, we will be having Debian. We can have Alpine. Okay, for each and every image, we will be having base image. For node also, we are having base image. And whatever layers we are having, all these layers are read only. We cannot change anything. We cannot add anything. These layers are read only. But after creating this application image, when we are creating the container, a new writable layer, okay, that is called as container layer. This will be added on top of these layers. So whatever layers we are having, these are read only. But when container is created, we will have one writable layer. So that is the reason when container is created, we will have access to its file system. We can create the file, we can delete the file, we can edit the file, we can do all the stuff which we are performing in our host operating system. Okay, so you can tell these layers are immutable in nature, which means we cannot modify or we cannot change anything. The only layer which we can change is our container layer, which is used when building or running a new container. So what is Docker layer? In Docker file, we are passing some instructions. From then we will be passing work directory, then we will be passing copy. So in Docker file, each and every instruction will be creating separate layer. Okay, together it is not going to execute. Each and every instruction is going to create separate layer. As one single block, Docker is not going to build the image. It will be creating separate layer for every instruction. For example, we are having two images. And in MySQL, we have already seen I'm having MySQL latest and I'm having MySQL 8th version. So in my system, I'm having two images. And these images will be made of multiple layers. So for this also, we will have multiple layers. And for this also, we will have multiple layers. So here I am working with same image but different versions of that image. So in this case, some layers might be common. For example, first I have just pulled this latest. I am having this layer. Okay, all these layers will be present. But when I am pulling this 8th version of MySQL, maybe this layer is already present. So in that case, I will have the message already exist. Again, it is not going to download that complete layer. Simply it will tell this content, this layer is already present. So again, we do not have to pull or download. So here Docker cache comes into picture. What this cache will be doing, it is just going to store previously built layers. While creating .ignore file, what I did, I deleted my container, I deleted my image, again I built. But in real world, we will not be doing like that. First we are building, again we can build on the same image. We do not have to delete anything. So what this Docker cache will be doing, it is just going to store previously built layers. So next time when we are building, then unchanged layers are reused. Again, we do not have to build, or again we do not have to download that image layer. Unchanged layers can be reused. So this is called as Docker caching. Okay, now I have built my application. I have used this command. Let me write Docker build -t my image name to do app. I will be passing current directory path. So Docker file will be executed. I am having from, then I am having work directory, then I have passed copy, then I have passed run command. Okay, then cmd, one by one these layers will be executed. Now suppose inside app.js I have changed something. Again when I rebuild this, again when I run this application, Docker will be checking. Let me come to Docker file. It will check, okay, this is not changed, this is not changed, this is not changed. While copying this, app.js is changed. So what Docker will be doing? It is going to use cached layers. So in this case, Docker is going to reuse all the cache layers. So building or execution becomes very fast. One more important point which you should know, this Docker cache, it is going to break from our changed layer onwards. Now imagine in this layer I have done some changes. So here cache will be broken and remaining whatever instructions we are having, that will be executed as it is. Maybe this layer is dependent on this one. So that is the reason if we are doing any change in this layer, from this layer onwards, this cache will be broken and no layers will be stored inside the cache. Again, everything will be rebuilt. But whatever is stored previously, that will not be rebuilt. So if this layer is changed, then this will be rebuilt and this will be rebuilt. This will not be changed. Okay, this will be reused and this will be reused. So here inside this is the bad Docker file. Let me tell you why. Because what we are doing here, we are copying all the files and after that we are running npm install. So which means whenever I'm doing any changes in my app.js or in any file, again after that I'm just going to run this npm install. Definitely I do not want this one. Why? Because inside package.json, whatever dependencies we are having, only once we are going to execute. Again and again, if I'm doing any changes to my code, I do not want to execute this run command. Okay, this is bad Docker file. So what we can do, below this working directory, I will write copy command. Then what I will copy? I will copy package.json. And in this to do app, I'm just going to copy only package.json. And after that, I will run npm install. Copy, cut it from here, and below this, I'm just going to paste. First, I'm copying package.json, and after that, I'm just going to run this npm install. And only after that, I will copy all the files and folders. So in this way, up and down, which I had written earlier, if we are writing, doesn't matter what changes we have done to our code, each and every time this command will be executed. Even if small change, all the dependencies will be reinstalled. Save this. I will come to app.js. Inside this, I will make some change. Okay, inside this, I am using dollar symbol. We should not be using this while creating the variables. Silly mistake. Open terminal. Again, I am going to build. Hit enter. Now you can see building will be very fast. Again, you do not have to delete the image or container. Directly, you can rebuild your application. So why layers are helpful? Layers are helpful in faster build, optimization, image reuse, it will reduce build time, and we will have smaller downloads. So this is the complete visual flow. Inside Docker file, we will be having all the instructions, and when we rebuild our application, separate layers will be created, and whatever layers we are having, we are going to store all the layers. Okay, we are doing Docker caching, and after that, if we are doing any changes to our code, from that layer onwards, our cache will be broken, but next build will be reusing all the cache layers. Again, it is not going to rebuild previously created layers. And finally, this is going to lead to faster builds. Before publishing, we need three things. First is Docker should be already installed in our system. This we have done. Second, in Docker Hub, our account has to be created. This we have not done. And whatever image we want to publish, that image has to be created. This also we have done. So now let us create the account in Docker Hub. What is Docker Hub? Docker Hub is online registry where we can store and share our Docker images, just like GitHub source code. So inside repositories, we will be pushing all the code. Similarly, in Docker Hub, we will be storing our Docker images so that if other developer wants the same application, they can easily download our image and create containers from it. So why we will publish images? So that other developers can use it. We can deploy anywhere easily. You can either share in public or you can share as private, and easily you can use in production. I have opened Docker Hub. If you are already having the account, click on sign in. If you are not having, then click on sign up. I will select personal. I will pass hanamteaching@gmail.com. Username, I am going to pass Hanam coding. Then I will be passing one password. Okay, pass the email, pass your username, and I will be passing password, and then click on sign up. You can sign up using Google or GitHub as well. Now one verification code has been sent to my email. I will enter that code. You can see from Docker, I have got this code. I will copy, and inside this, I'm just going to paste. Now click on verify. Verification successful. Proceed to sign in. Again, whatever password I have given, I will be passing that password. Click on continue. Now this is my account. Click on this drop down hub. Here we are having repositories. Click on that. As of now, I am not having any repositories. I have to create new repository. Like how in GitHub, we will be creating the repository and pushing all the code. Similarly, here inside the repository, we are just going to push the image which we have created. I will click on this create repository. Repository name, I will pass to do app. Okay, whatever name you want, you can pass. You can pass short description. In free plan, you can use one private repository. So I will be selecting public and click on create. Repository is created. Now this repository name is going to matter a lot, and this name is assigned by Docker when we created our repository. Now whatever image we have created locally, that we will not be using. We are going to build a new image, and for that image we will be passing the exact same name so that pushing becomes easier. I will come in CMD. Step by step you have to follow. First thing, we have to log into Docker Hub from our terminal. Okay, previously if I would have logged in, then what I will do, I'm just going to log out. Okay, it will remove all the login credentials. Then I'm just going to log in, Docker login. As soon as I write this, here I will be having some information, but I'm just going to open this link. Inside this, for one-time device confirmation, I am having this code. I will copy, and inside this, I'm just going to paste and click on continue. I will click on confirm. You can see, congratulations, you are set. Now, this terminal is connected to our Docker Hub account. You can see we are having login succeeded. Now I will build Docker image. Before that, I will come to images. From here, I'm just going to delete this to do app. Okay, whichever image we have created earlier, I'm just going to delete. And this container also I will be deleting. I do not need. First, let me check. Okay, this is Mongo and Mongo, and this is the container I'm just going to delete. Now what I will do, now I'm just going to build the image. docker build -t. Now I will give the image name as this one. Okay, complete repository name. I will copy and here I will be pasting. And then I have to pass current directory path. Hit enter. Now you can see building has started. One by one, again, whatever we have done, it is going to do. Now I will do Docker images. Hit enter. My image is created. You can see image is created. Inside this Docker desktop also, I can see my image. Now you might be having question. Previously, we have created the image. Then why again we are building this image? Because Docker Hub requires specific image format. Whenever we are building the image in Docker Hub, we are going to pass our username, and after that, whatever image we want, we will be passing that name. So that is the reason again I have rebuilt using this username and my image name. Okay, we have created the image. Now finally, we are going to push this image in Docker Hub. For that, we will write Docker push and that username / our image name. It will be having latest version. One by one, all the layers will be pushed and it is going to refer to this repository. You can see in this way, our image name will be present. So internally, what it is happening, it is going to check all the layers. It will upload all the image layers and finally store that image on Docker Hub. At the end, if you're getting this line, that means successfully our image is pushed in Docker Hub. Let us verify. I will open Docker Hub, refresh once. Now, as soon as I refresh, you can see in general, I am having latest, which means when we pushed our image, it will be having latest version. And inside this tags also, we can see this, okay, our image is pushed. And inside this image management also, you will be seeing all this information. And inside image management also, you will be having some information. Sometimes what happens, even after pushing, it will take 15 to 20 minutes to update in general and tags. Once you see information inside image management, it is verified our image is pushed inside Docker Hub. Let me come to tags. If you want to push any other versions, you can use this command. But if you want to pull this image, you can see we are having this command. By default, for latest, we will not pass :latest. Successfully, we are able to push our image in Docker Hub. Now we have pushed the image. If any developer wants this image, they can just pull the image. They can use in their system. They don't have to install any dependencies because we have written all the instruction. But I will not stop here. I will also show you how to pull an entire thing we are going to run again. So in between, we have to do some changes to our code and we have to rebuild. I will be telling you why we have to make the changes. So first, let me come to tags. To pull the image, again same thing, Docker pull image name. From here, I will copy. I will not pass :latest. And inside this, I'm just going to paste. Now you can see, I will be able to pull my image. All good. Now what we have to do? We have to create the container. For container, I will write Docker run and my image name. I will copy image name and inside this paste. Hit enter. Now I am having server is running on port 3000. Open browser. I am getting the message, but as soon as I open this, I will not be able to access this site. Even if I refresh multiple times, I will not be able to access. Now let me come here. Let us wait for few seconds. In terminal, I will be having complete error message shown. See, I am having complete error message. And what error we are having? Mongo network, it is unable to connect. In our application, we are passing local host and we are trying to connect our Mongo database. But it is not working. Let us understand why. Previously, we have created YAML file and inside this, we have passed two services, Mongo and Mongo Express. If we run compose command, both the images will be pulled, containers will be created, and Mongo Express will be in same network. Now what we did, we have created our application, okay, Node.js container. And by default, whenever we are creating container, it will be in default network. Okay, we have understood in networking concept. So our application and Mongo Express, they are not in same network. Only these both can communicate with each other, but our node application is not able to connect or is not able to communicate with our Mongo container. So what we will do, inside this YAML file, we will write Mongo, we will write Mongo Express, and also whatever image we have pulled now, that image also we are going to pass inside the service, so that all these three containers will be lying inside one network. So easily our node can communicate with Mongo, and then easily we can have access to this localhost 3000. Let us make some changes. So first thing, we should not be passing localhost. I will be passing Mongo. Whatever service we are having, that I will be passing. Okay, now Node.js, Mongo and Mongo Express all will be in same network, so easily they can communicate. Now below this, or you can also write here, I will write another service. I will pass the service to do app. Then I have to pass the image. What is my image name? My image name is Hanam Coding to do app. Give indentation. Indentation matters a lot. Give one space as well. Below this, I will be passing codes. Let me pass hyphen. I will write 3000, and I'm just going to bind with container port. Next, what we have to pass? We have to pass environmental variables. Come to Docker file. Here, I have created these two variables. I will just copy, and from here, I'm just going to cut. Save this. Come to YAML file. Directly inside this, I will define environmental variables. I will write here colon, and here also I will be passing colon. Remove this slash and then give one space. Indentation matters. Then I will be passing one more setting, depends on. This application depends on which container. It depends on our Mongo container. Environmental variables we are passing here, and this depends on, just bring here, save this. Environmental variables we are already passing in YAML file, so in Docker file you do not have to pass, but in app.js you don't have to change anything. Whatever variable we are passing, exact same variables we are using here, and here simply change to Mongo. Once all these changes are done, clear terminal. Again, I'm just going to build my app. Hit enter. It will start building. Once it is done, I'm just going to push this updated code in Docker Hub. Some layers are already existing, so it will be taking from cache, and I will have the message layer already exists. Whatever changes we have done, only that particular layer will be updated. Now successfully it is pushed. You can see we have built the image. But what I will do, whatever images and containers I am having, I'm just going to delete all that. And my complete application I have pushed in Docker Hub. Now imagine you are another developer and you are trying to pull that complete application. So what you will do, you will write Docker pull. Let me use arrow. I'm just going to pull my complete application. Now you can see it will start pulling. Let us wait. Now in my Docker desktop, I am having my image. Inside YAML file, I have defined all my containers. So I will run Docker compose up. That's it. As we have mentioned, for our application, we have mentioned depends on. So that is the reason only once our Mongo image is pulled, or only once our Mongo image is downloaded successfully, our application downloading will start. Mongo image is pulled, Mongo Express image is pulled, default network is created, and we are having three containers. If I just scroll down, somewhere I will be having our server is running on port 3000. Now what I will do, I'm just going to run in detach mode. I will just click D. Open Docker desktop. Inside these images, in total, I am having all three images. And inside these containers, if I just click, I am having Mongo, Mongo Express, and my node application. All will be running in same network. After making all the changes, I will come here. Now I will refresh this. You can see I am able to open my application. Very, very important. Most of the time you will be confused after pushing the image how to pull and how to execute. So that is the reason I have shown you all the steps. I can also access my Mongo Express. Hit enter. You can see to do app. We have already written Docker volumes. So that is the reason our database is present, collection is present, and whatever document we have added, that is also present. Till here, successfully, if you have got the output, mention in comment section. so that it will motivate others. But if you're having errors, that also you can mention in comment section so that we can help each other. The more Docker problem you solve, the stronger Docker developer you are going to become. Beginning, Docker might feel confusing, but after building project, you will realize Docker makes our development much easier, cleaner and professional. Okay, one important interview tip, do not memorize or do not by heart any Docker definition because interviewers will be loving real explanation of the project. For example, if you have created any project and there if you have used Docker, you can simply explain I have created MERN application with the help of Docker Compose where I have used React as a front end, Node as a backend and Mongo as the database, and for all these three, I have created containers and I have connected them using custom networks so that they can communicate with each other. And also, I have used volumes for MongoDB so that I can persist my data and also environmental variables for all the configurations. Okay, this sounds much stronger in interview. Now, it's your time to practice each and everything. Next, you will be seeing list of some interview questions which might be asked in interviews. Congratulations again, you have completed Ultimate Docker Masterclass. Thank you so much for watching this complete course. Bye. I will see you in next course.